Hello there and welcome back to the Sleep Science. Tonight you find yourself staring into a sky that looks perfectly ordinary, a velvet dome scattered with stars until, without warning, the canvas seems to tear. A vast patch of nothing yawns before you, darker than the surrounding dark, a hollow space where your eyes almost expect light but none comes. It's the kind of sight that makes you instinctively pull the blanket up tighter, because some quiet corner of your mind whispers, you probably won't survive this if you actually fall in. Still, here you are, leaning closer, drawn toward the most unsettling gap in the universe we've discovered so far, the Boötes Void. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, let me know in the comments where you're tuning in from and what the local time is right now. I love seeing the scatter of time zones. It's like our own little galaxy cluster down in the chat. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You stretch your senses and let yourself drift upward, above your room, above your city, past the faint golden glow of human civilization. At first, Earth feels enormous, but once you push out into orbit, it becomes a fragile bead floating in ink. The International Space Station flashes by like a toy. Satellites sparkle briefly, then fade. Your lungs would already be out of air if this were a real trip, but fortunately, this is the Sleep Science channel, where oxygen tanks come free of charge and helmet hair is never an issue. Past the moon, past Mars, past the belt of rocks tumbling silently, you find the stars are no longer individual neighbours, but woven into shimmering threads. These are the filaments of the cosmic web, massive highways of galaxies stretching across billions of light years, and right away you notice something odd. Those filaments aren't evenly spaced. Where there are clusters, there are also gaps, hollow regions like bubbles in foam. Scientists call them voids, and they're not unusual, but as you hover higher, looking down at the cosmic froth, one gap pulls at you like a drain in a swimming pool, the Boötes Void. It sits in the northern constellation of Boötes the herdsman, a figure humans have traced in the stars since antiquity. The Greeks imagined a ploughman driving the great bear across the sky. Romans tied the constellation to their myths of harvest and fertility. But if any ancient shepherd ever pointed his crook toward the Boötes Void, he would have seen nothing strange, just a patch of night as ordinary as any other. The human eye simply can't grasp emptiness at that scale. It took modern telescopes and the meticulous charting of galaxies to realise there was a hole so immense it made astronomers blink twice and recheck their math. Imagine this. The Boötes Void is about 330 million light years across. Not million miles, not million kilometres, light years. To give your sleepy brain a handle, that's a sphere so wide you could line up 2,000 Milky Ways edge to edge, and still have room to spare. It's like taking the United States, scaling it up to the size of Jupiter, then tossing it into a canyon that dwarfs everything else. The numbers are so vast that your mind does what it always does when faced with cosmic scale. It shrugs, chuckles nervously, and files the problem under "not my business." Here's a mainstream historical fact for you. The Boötes Void was first identified in 1981 by astronomer Robert Kirshner and his colleagues at the University of Michigan. They were mapping the redshifts of galaxies, that is, how their light stretches as the universe expands, when they noticed a massive spherical gap. At first glance it looked like a glitch, the kind of error that creeps in when your telescope sneezes or your data printer gets cranky. But the more they checked, the clearer it became. The universe had built itself a yawning cavern, a black bubble where almost nothing lived. And here's a quirky tidbit you'll enjoy. In the early days, some amateur astronomers and sci-fi fans playfully nicknamed it the Great Nothing, as if the universe had dropped its sandwich while painting galaxies and left a blank grease spot on the paper. Forums buzzed with the idea that maybe it was an intergalactic parking lot, cleared out by hyper-advanced aliens who didn't want neighbours. One particularly cheeky theory even suggested it was a cosmic shooting range, a safe space for universes to test their superweapons without worrying about property damage. Spoiler alert, no laser tag found so far. Historians still argue whether Kirshner's discovery moment truly reshaped cosmology or simply confirmed suspicions that large voids must exist. After all, cosmic maps were already hinting at bubbly structures. But the Boötes Void wasn't just a bubble, it was the mother of all bubbles, The kind of thing that forces scientists to sit down, sip their coffee, and mutter, "Well, that's inconvenient." And here's where you pause, because the sheer silence of the place presses in. If you were floating at the centre of the Boötes Void, the nearest major galaxy would be hundreds of millions of light years away. The night sky, instead of being freckled with thousands of stars, would be desperately underwhelming. You might glimpse a faint smudge here, another dim spark there, but otherwise the dome above you would feel like an abandoned theatre. Stage lights switched off, curtains drawn. If loneliness had a physical form, it might look a lot like this. Of course, humans can't resist putting themselves into the cosmic story. You imagine some poor astronaut stranded in a spaceship inside the void. No chance of rescue, no friendly constellations to guide by, just a radio buzzing with static. The kind of setting horror writers drool over. If Earth feels insignificant compared to the Milky Way, then a human inside the Boötes Void would feel like a speck of dust lost in an empty shopping mall the size of a continent. And you know what's worse? Even the dust bunnies are missing. Still, emptiness has its own strange beauty. You think of deserts on Earth, vast dunes where the silence is almost physical, pressing against your ears, or the deep ocean, where divers switch off their lights and hover in blackness so complete it feels like velvet draped over their bodies. The Boötes Void is that experience magnified to the cosmic extreme. It isn't hostile exactly. It isn't trying to hurt you. It's just indifferent. And sometimes indifference is scarier than malice. A soft joke to lighten the mood. If the Boötes Void were real estate, it would be the worst neighbourhood listing ever. Spacious property, minimal light pollution, zero amenities, neighbours may take 1 billion years to visit, Zillow would cry. As you float deeper into this narrative, you realise that emptiness is never truly empty. Space still hums with quantum particles, with background radiation from the Big Bang, with the thin whisper of hydrogen atoms drifting aimlessly. Even in the void, physics refuses to clock out, and in a strange way, that makes you feel a little less alone. But still, the first impression remains. A hole in the universe so big, so unignorable, that it almost feels like the cosmos is hiding something behind its back. Like a magician telling you to focus on the left hand while the right hand palms the card, and whether or not there's truly anything to hide, your curiosity has already taken the bait. You turn slowly, as though adjusting your vision to darkness that will never brighten. Galaxies around the edge of the void look like nervous party guests clustering at the wall, reluctant to step onto the empty dance floor. You wonder, why does the universe build itself this way? Why all the gathering here and the nothing there? That question will haunt you, tugging at your sleeve, all the way through tonight's journey. For now, though, you let yourself exhale, drifting in place. Your ears almost ring with the hush of it, the kind of silence that makes you think you can hear your own blood moving. Somewhere far away, Earth keeps spinning, utterly unaware that in the constellation of Boötes, a hole the size of cosmic imagination itself sits patiently waiting for us to notice. And now, you've noticed. You keep staring into the hollow, and after a while the question nags louder. How did anyone even realise this empty space existed? To your naked eye, the night sky always looks busy. Stars scattered like glitter on black paper, constellations stitched by centuries of human storytelling. Nothing about Boötes looks unusual at first glance. If anything, it's just another familiar corner of the northern sky, where the bright star Arcturus burns orange like a lantern hanging from the herdsman's crook. But appearances, as you've just learned, can be cosmic-level liars. Astronomers don't trust appearances. They measure, chart, and catalogue until the universe gives up its secrets. And in the mid-20th century, that meant long nights at telescopes, squinting at photographic plates, and later, punching numbers into computers that took up whole rooms. To them, the sky wasn't a flat dome of twinkling lights. It was a three-dimensional space filled with galaxies, each one moving, each one telling a story. The trick was to map it properly. That's where redshift comes in. You remember how an ambulance siren drops in pitch as it drives away? That's the Doppler effect. Light does the same thing. Galaxies rushing away from us, thanks to the expanding universe, stretch their light toward the red end of the spectrum by measuring how red the light becomes. Astronomers can estimate the galaxy's distance. Stack enough of these measurements together, and you don't just see stars in the sky, you see a cosmic atlas, with depth and dimension. By the late 1970s, surveys were finally reaching far enough into deep space to reveal patterns. Astronomers like Robert Kirshner and his colleagues in the Seven Samurai group, yes, that's what they called themselves, because if you're mapping galaxies you're allowed a little cinematic flair, were busy charting thousands of galaxies. And then came the head-scratching moment. They stumbled across a patch of sky where the redshift data seemed to vanish. Instead of the usual spattering of points, their map showed a blank spot as though someone had taken an eraser to the chart. At first, of course, the assumption was error. Maybe the telescope missed those galaxies, maybe the instruments hiccuped, or maybe, more embarrassingly, someone dropped a donut crumb on the photographic plate. You can laugh, but crumbs have sabotaged greater projects. Yet the blank patch kept reappearing, bigger and bigger, no matter how they adjusted their methods. By 1981, the team had to admit the obvious. They had found a true void, a bubble in the cosmic web unlike anything else mapped at the time. Here's your mainstream historical fact. The Boötes Void was officially announced in 1981, in a paper that immediately sparked debates about large-scale structure in the universe. It wasn't the first void ever discovered, but it was by far the largest anyone had identified. At roughly 330 million light-years across, it made other voids look like potholes compared to the Grand Canyon. Now, for a quirky tidbit, one of the early press write-ups described the void as a hole in the universe big enough to fit 2,000 Milky Ways, which, while technically accurate, caused more than a few readers to imagine a literal tunnel bored through space, as if the universe were Swiss cheese. Somewhere, a science writer must have chuckled at how their metaphor spiraled into cheese jokes that linger to this day. Historians still argue whether the Boötes Void's discovery was a watershed moment or simply a flashy confirmation of models that already predicted voids. After all, cosmologists had long suspected that the universe's large-scale structure resembled foam, with filaments of galaxies enclosing hollow bubbles. The discovery didn't rewrite the textbooks overnight, but it gave the concept a vivid, headline-friendly mascot, the Great Nothing. Picture yourself as one of those 1980s astronomers, sitting in a chilly observatory, your desk piled with stacks of punched cards and printouts. You shuffle through the galaxy catalogue and suddenly realise there's this absurdly huge patch with practically nothing in it. Your first instinct might be mild panic. Did you misalign the telescope? Did you spill coffee on the datasheet? But the more you verify, the bigger your grin grows, because sometimes in science, nothing is the most exciting something. You glide alongside those astronomers now, peeking over their shoulders as they plot dots on a 3D map. Most of the sky looks like a starry spray paint job. Thick clusters here, thinner patches there, and then, bam, a yawning bubble with only a handful of lonely dots inside. If you squint, you might mistake it for an unfinished section, like a puzzle with missing pieces. But the universe doesn't owe us completion. It leaves blank spaces on purpose. The funny part, if you went outside tonight and looked at the Boötes constellation with your own eyes, you wouldn't see the void. The galaxies that line its edge are too faint, too far. All you'd see is Arcturus and its neighbours, twinkling innocently. The void is invisible without instruments and math, like a hidden trapdoor in the sky. Nature's way of hiding the elephant in the room by draping it in perfect camouflage. To help you visualise, imagine you're baking bread. The dough rises, and bubbles form inside, pushing the yeast outward. When you slice the loaf, you see those airy holes scattered throughout. That's the large-scale universe. Galaxies clump along the edges of expanding bubbles, leaving cavernous voids in between. The Boötes Void is just an especially gigantic bubble, the kind that makes you wonder whether the baker, meaning in this metaphor cosmic inflation, got a little carried away. You lean in closer. What's astonishing is not just the size, but the sparseness. Based on averages, there should be thousands of galaxies inside that volume. Instead, there are only a couple hundred, and most of those huddle closer to the edges. At the centre, practically zilch, like a desert where you'd expect an ocean. And you can't help smiling at the irony. Humans spent centuries trying to prove we weren't at the centre of the universe, only to discover that somewhere out there really is a centre of nothing. If our planet had been born inside that void, we might have never discovered other galaxies at all. Our telescopes would have looked out at emptiness and assumed the universe was a lonely place, barren of neighbours. Talk about cosmic bad luck. Still, emptiness has its own poetry. The maps drawn by those astronomers in the 80s look almost like abstract art. Dots clustered in filaments with haunting blank circles. If you didn't know it was a galaxy survey, you might hang it on your wall as a minimalist print. The void isn't just absence, it's negative space shaping the structures around it. Without emptiness, the clusters wouldn't have definition. Here comes a little joke to soften the eerie mood. Imagine if aliens inside the void invented their own astronomy. Their textbooks would feature very short chapters. Chapter 1. There is nothing to see. Chapter 2. Still nothing. Conclusion. Let's just go back to farming. But the story of the Boötes Void is more than just a curiosity. It became a rallying point for the study of cosmic structure. Once scientists knew what to look for, they started identifying other large voids, tracing the foam-like architecture of the universe. By the 1990s, massive surveys like the CFA Redshift Survey and later the Sloan Digital Sky Survey painted ever clearer pictures of the web. The Boötes Void wasn't unique anymore, but it remained the poster child, the celebrity hole in the universe. Think of it like the Grand Canyon. There are plenty of canyons on Earth, but the Grand Canyon steals the show because of its sheer scale and the drama of its discovery. In the same way, the Boötes Void became the iconic emptiness, a benchmark against which other voids were measured, and yet the map is still being refined. Even today, astronomers use more powerful telescopes and new algorithms to check whether the void is perfectly spherical, whether it connects to other voids, whether its boundaries ripple or blend into filaments. Like cartographers in the age of exploration, they're still sketching the edges of the blank. You can almost picture "Here be dragons" written across the cosmic chart. Though in this case it's more like "Here be absolutely nothing." By now you feel the weight of the discovery pressing down gently, like a hand on your shoulder. A patch of missing galaxies, revealed not by eyesight but by persistence, by rows of numbers, by a willingness to trust that blank spots are worth investigating. The Boötes Void teaches a quiet lesson. Sometimes the most important thing on the map is the thing that isn't there. You're still hovering beside those astronomers' maps. But now the question sharpens. Just how big is this hole really? The words enormous and huge don't quite cut it. Our human brains are built for grocery lists and parking spaces, not intergalactic geometry. To measure something like the Boötes Void, you need both math and imagination. A double toolkit to stretch across scales that don't fit neatly inside a bedtime story. But lucky for you, we're about to attempt it anyway. Start simple. The Boötes Void spans about 330 million light-years. You roll that phrase around in your head, and it sounds like a trivia fact you'd pull out to impress or terrify your friends at a party. Did you know there's a hole in the universe so wide that light, the fastest thing in existence, would take 330 million years just to cross it? Cue the awkward silence, followed by someone nervously asking if you're okay. But let's unpack it. A single light year is nearly 6 trillion miles. Multiply that by 330 million, and your calculator politely short-circuits. The number is so massive it doesn't really exist in your daily vocabulary. To help your brain cope, imagine this. If you hopped into a spaceship travelling at the speed of light, no bathroom breaks, no snacks, just raw zoom, it would take you longer than the age of the dinosaurs to cross from one side of the void to the other. You'd have started when T-Rex was stomping around and still be going today, not even close to reaching the other wall. Here's your mainstream historical fact. Astronomers calculated this size by meticulously measuring the redshifts of galaxies along the void's edge. Each galaxy's light stretched a little more, revealing its distance. By stacking these measurements across the region, they could trace the boundaries of emptiness like surveyors marking the edges of a field. It wasn't perfect. There's fuzziness at the edges. But the scale was undeniable. The void wasn't just a gap. It was a kingdom of nothingness large enough to embarrass our home galaxy. Now, for a quirky tidbit, one researcher joked that if you shrank the Milky Way down to the size of a pea, then lined up 2,000 peas in a row, you'd just about span the void. Of course, someone in the audience apparently asked if they could then eat the pea galaxy salad afterward. Science conferences, part cosmic wonder, part awkward potluck. Historians still argue whether measuring voids is an exact science or more of an interpretive art. Do you count faint dwarf galaxies inside the hollow, or only the big spirals? Where exactly do you draw the edge, since density gradually rises instead of dropping off like a cliff? The Boötes Void in particular sparked debates that continue today. Some claim it's one big unified void. Others think it might be a chain of overlapping smaller voids that just happen to stack together like bubbles merging. The jury, as always in cosmology, is still out, but numbers only take you so far, so let's switch gears and feel it. Imagine you're floating inside the void, slowly gliding forward. You'd expect stars, galaxies, the comforting sprinkle of light. Instead, the universe here feels thin, stretched, diluted like a weak cup of tea. Your view is filled with blackness, punctured only by the faint smudges of a few lonely galaxies clinging near the edges. Those smudges are so faint that if you were using human eyes instead of your trusty imagination telescope, you'd likely miss them altogether. Now extend your arms and trace a circle around yourself. Except your circle is so vast it could swallow the Virgo supercluster, the collection of galaxies our Milky Way belongs to several times over. Inside that circle, almost nothing answers back. It's not just empty, it's emphatically empty, the kind of void that makes you rethink what space really means. To help anchor your thoughts, let's scale it down to earthly distances. Suppose the entire Milky Way shrank to the size of a frisbee. In that model, the Boötes Void would be a yawning football field with only a few other frisbees scattered along the bleachers. You, standing in the middle, would feel absurdly exposed. And because we're going for cozy sarcasm bedtime vibes, let's just admit, the frisbee analogy still doesn't capture how lonely this place would feel. It's cosmic introversion, turned up to maximum. Of course, measuring a void isn't just about showing off big numbers. Scientists want to know why it exists, how it formed, and what it tells us about the universe's evolution. But to even begin answering those questions, they needed to be sure about the size, so they double-checked, rechecked, and eventually used computer simulations to confirm that yes, this void was consistent with large-scale cosmic structure. It wasn't a data error, it wasn't an observational fluke, it was real, and it was enormous. And now, for a playful joke, if you ever feel like your apartment is too small, just remind yourself that at least you're not paying rent on 330 million light-years of nothing. Imagine the heating bill. The fun part about measuring voids is that you're not just counting galaxies, you're counting the missing ones. Based on cosmic averages, astronomers estimate that inside the Boötes Void there should be roughly 10,000 galaxies. Instead, they've found maybe a few hundred, scattered like crumbs at the bottom of an otherwise empty chip bag. And just like when you find only crumbs, the disappointment is palpable. Where did all the galaxies go? Did they never form? Were they pushed outward by gravitational flows? Or is there some trick of dark matter and energy at play? Those are the mysteries that keep the measurements interesting. But back to your perspective. Imagine flying a probe into the centre of the void. The cameras pan outward, and the images come back not with colourful swirls of galaxies, but with darkness. Scientists might squint at the faintest speck of light, circle it on the monitor and cheer, "Galaxy detected," as if they'd just spotted a celebrity cameo in a crowded movie scene. That's how sparse the place is. Each lonely galaxy becomes precious, a gem in the desert. And speaking of deserts, here's a comparison you'll like. The Sahara, though empty of water and shade, is actually buzzing with life if you look closely. Plants, insects, reptiles, caravans. The Boötes Void, by contrast, is less lively than a cactus graveyard. If the Sahara is silence, the void is the silence after silence, a hush that makes even silence itself feel noisy. As the measurements grew more refined in the decades after 1981, astronomers realised that voids aren't accidents. They're an essential feature of the cosmic web, shaped by gravity tugging on matter after the Big Bang. They grow larger over time, like bubbles merging in rising dough. The Boötes Void, then, is both a curiosity and a clue, a measuring stick for how emptiness evolves. The sheer act of quantifying it opened the door to entire new branches of cosmology. One last thought before you drift onward. The measurements remind you that emptiness can be just as real, just as measurable, as matter. You don't always measure what's there. Sometimes you measure what isn't. And in a universe filled with galaxies and stars, that kind of absence is a loud whisper, telling us the shape of everything else. You hover at the edge of the Boötes Void, staring into its dark interior, and the strangest thought strikes you. This emptiness isn't supposed to exist. Not like this. According to the cosmic average, this hollow space should be bustling with galaxies. Tens of thousands of glowing spirals and ellipticals should be strung across your view like lanterns at a festival. Instead, you see a smattering, barely a few hundred. It's like walking into a stadium during the championship game and finding only 6 confused fans clapping politely in the front row. Something feels off. The universe, after all, is usually generous with galaxies. Across most of the cosmic web, they appear in predictable densities, clustering along filaments but rarely abandoning entire regions. Astronomers expected voids, yes, but not deserts quite this bone dry. If you could bottle the average portion of the universe, say a cube a few hundred million light years on a side, you'd usually scoop up thousands upon thousands of galaxies. The Boötes Void stubbornly defies that expectation. It's underpopulated to the point of awkwardness. Here's your mainstream historical fact. When Robert Kirshner and his team first announced the void in 1981, their estimates suggested that the region contained fewer than 60 galaxies, where about 2,000 were expected. Later surveys increased the count a bit, but even today the census is laughably low compared to the cosmic norm. It's like rolling dice 10,000 times and somehow only getting snake eyes. And for a quirky tidbit, one astronomer described the void as a place where galaxies go to be lonely, which sounds like the start of a very emo space poem. Someone else joked that the few galaxies inside must all know each other personally. Maybe they even share one intergalactic neighbourhood Facebook group where the posts are just, "Still nothing happening out here." Anyone want to borrow some hydrogen? Historians still argue whether the scarcity of galaxies inside the Boötes Void is due to initial conditions from the early universe or later gravitational dynamics. Did the void simply start off with less matter, dooming it to eternal emptiness? Or did nearby structures, through the subtle tug of gravity, slowly evacuate it like a cosmic sinkhole? Both scenarios are possible, and both remain open debates in cosmology. For you, though, the mystery feels more visceral. You picture yourself drifting inside, counting galaxies like someone counting pebbles on a beach. 1, 2, 3, and then nothing for miles. 4, 5, maybe a faint smudge on the horizon. It's an exhausting scavenger hunt with very few prizes. The emptiness begins to weigh on you, not because there's anything threatening about it, but because the silence presses so hard against your imagination. And yet, even in this near void, a few stubborn galaxies survive. They shine faintly, like porch lights in an abandoned neighbourhood. Imagine living in one of those galaxies. If your planet had intelligent life, you might gaze into the night sky and see nothing but a lonely sprinkle of stars. You'd never guess that, far beyond the void, there are cosmic cities teeming with galaxies. Your worldview would be claustrophobic, your philosophy tinged with solitude. Perhaps your species would never invent cosmology at all, because why bother if the universe looks so empty? Here's where the eerie fun comes in. What if we had been born inside the Boötes Void? Our telescopes would scan the heavens and find only a few dim smudges. Edwin Hubble might have concluded that our galaxy was the only one, reinforcing the old belief that we were the centre of everything. The entire trajectory of science and philosophy could have been derailed. The void isn't just a curiosity, it's a reminder that our cosmic neighbourhood is unusually well lit. We're lucky to live in a galaxy cluster, where neighbours abound. In the void, loneliness would have rewritten history. Still, you can't shake the feeling that something is missing. Like an empty shelf in a library, the absence of galaxies almost calls more attention to itself than their presence would have. You think back to Section 3, how astronomers measured what wasn't there. Here, the absence becomes personal, as if you're walking through a party where all the guests cancelled. The dance floor is clean, the lights are on, but nobody showed up. A little joke to ease the tension. If galaxies were people, the Boötes Void would be that one unpopular high school party where the host spends the night pretending they actually like smaller gatherings. Astronomers, of course, don't settle for jokes. They want answers. They run simulations, tweaking conditions of the early universe to see how voids like this might form. Some models suggest that small fluctuations in density after the Big Bang could snowball, creating regions with fewer galaxies. Others argue that dark energy, the mysterious force accelerating cosmic expansion, might play a role. subtly pushing matter out of certain regions over billions of years? The truth is, no one's sure. And the Boötes Void sits there like an unsolved riddle, daring us to keep guessing. As you drift deeper, you notice something subtle. The galaxies inside the void don't cluster in the middle. Instead, most cling to the edges, as though afraid of the centre. It's like a cosmic game of musical chairs where everyone decided the middle of the room was off limits. Only a few truly isolated galaxies wander closer to the void's heart, stranded in solitude. Those rare stragglers fascinate astronomers. How do they form stars without nearby galaxies to mingle with? How do they evolve in such isolation? Do they feel the same loneliness you feel now, or are they content to burn quietly in the dark? The contrast with the rest of the universe is stark. Step outside the void, and you're back in familiar territory. Clusters, filaments, sprawling chains of galaxies weaving the cosmic web. Step back inside, and the lights go out again. It's the sharpness of the boundary that unsettles you, the way fullness gives way to emptiness like stepping off a cliff. And here's another thought experiment. Imagine that every galaxy is a city, its lights glowing against the night. The universe, then, is a globe peppered with brilliant metropolises, highways of civilization glowing along the filaments. The Boötes Void is the barren desert between them, a patch of wasteland where travellers dare not linger. If the universe were a road trip, the void would be that endless stretch of highway with no gas stations, no diners, just tumbleweed and silence. Better hope you brought snacks. One final comparison to ground the scale. In our local universe, the Virgo cluster alone contains about 2,000 galaxies. That's just one cluster, a single knot in the cosmic web. By rights, the Boötes Void could have hosted dozens of clusters like Virgo. Instead, it holds only scraps. Imagine moving into a mansion and finding only a folding chair in the middle of the ballroom. That's the absurdity of this place. And yet, you can't help but feel a quiet awe. The void, stripped of its galaxies, becomes something else, a monument to silence. It tells you that the universe isn't uniform, that chaos and imbalance are written into its very fabric. It whispers that our existence, tucked safely into a busy corner of the cosmic web, isn't guaranteed. We live in the lit district of the universe. Others, if they exist inside this void, are stranded in the dark. You lean back, letting the scale wash over you. Galaxies that should be there aren't. Galaxies that do exist inside are marooned. The universe isn't just about stars and light, it's also about the haunting beauty of absence. And the Boötes Void, the great nothing, is the grandest reminder of that truth. You're still hovering in that vast hollowness, but now your perspective shifts outward. If the Boötes Void feels like a desert, then the rest of the universe is an ocean. The cosmic web, those tangled filaments of galaxies, resembles foamy surf when viewed from afar. Bright lines and clusters marking where matter gathered after the Big Bang. Against this vibrant lattice, the void looks even starker, a parched expanse in the middle of abundance. Think about Earth for a moment. Deserts exist because oceans and forests don't stretch everywhere. The Sahara is only dramatic when compared with the lush equatorial jungles or the fertile Mediterranean. Likewise, the Boötes Void earns its haunting reputation not just from its size, but from the richness of the universe around it. Everywhere else you look, galaxies sparkle in strands and walls, like beads on strings, creating cosmic continents. The void, by contrast, is a blank page in an otherwise densely written book. Here's your mainstream historical fact. In the 1980s, as surveys expanded, astronomers began to realize that the universe wasn't evenly sprinkled with galaxies. Instead, matter arranged itself into massive walls and sheets, structures so large they dwarfed anything imagined before. One famous example is the CFA2 Great Wall, discovered in 1989, stretching over 500 million light-years. These discoveries confirm that the universe is filamentary, with voids like Boötes forming the spaces in between. The cosmic web analogy wasn't just poetic, it was literal. And here's your quirky tidbit. One researcher once described the cosmic web as looking like cold noodles floating in broth. Galaxies are the noodles, voids are the broth. Suddenly the universe sounds less like majestic infinity and more like last night's ramen. Somewhere out there, a grad student was almost certainly eating a cup of noodles while nodding in agreement. Historians still argue whether the cosmic web formed strictly from initial quantum fluctuations after the Big Bang, or whether later processes like dark energy reshaped it dramatically. Was the universe's frothy structure baked in from the very start, or did billions of years of expansion stretch and exaggerate it? This is one of those open debates that keeps cosmology deliciously unsettled. From your drifting vantage point, you can almost see the pattern. Step far enough back and the Boötes Void looks like one bubble among many, a single desert tucked between galactic forests. The contrast is stunning. Along the edges, filaments blaze with galaxies, superclusters tangle like glowing highways, then suddenly nothing. You're looking at the boundary between cosmic abundance and cosmic poverty. It's like flying over the Nile River, where lush green clings to the banks and then, within a mile, the sand of the Sahara swallows everything. And because we're leaning into sleepy sarcasm tonight, if the cosmic web is an ocean, then the Boötes Void is one of those no-swimming zones. No lifeguards, no beach bars, no fun floaties, just an endless stretch of water so flat and empty you start wishing for a single crab to crawl by. To grasp just how weird this contrast is, let's think of numbers again. In a rich region of the cosmic web, galaxies can cluster at densities hundreds of times greater than average. Picture them like glowing skyscrapers packed into Manhattan. The Boötes Void, meanwhile, is the rural farmland of the universe, flat, wide, and practically empty. If the universe were a city map, this would be the patch of cornfield with one gas station and a suspiciously quiet diner. But deserts and oceans aren't just metaphors. They teach you something about balance. The desert exists because rainfall elsewhere is abundant. The void exists because matter elsewhere clumped together. The Boötes Void, then, is a cosmic consequence. Without emptiness, the fullness of galaxy walls wouldn't exist. The two are inseparable, yin and yang written on the scale of light years. Let's indulge in another visualization. Imagine you're an intergalactic sailor. Your ship glides along filaments, docking at galaxy clusters like bustling ports. The universe feels alive. Trade routes, neighbours, communities. But then you cross into the Boötes Void. Suddenly it's weeks of travel with no stars, no stations, no company. Your crew gets restless. Supplies run low. You sing songs just to drown out the silence. And when you finally emerge at the far edge, galaxies blaze again like city lights after a long road through countryside darkness. That moment of relief is what makes the void so striking. Another joke to keep things buoyant. If galaxies are fish, the Boötes Void is that one aquarium at the pet store where all the tanks are labelled out of stock. You stand there staring at murky water, wondering why you paid admission. Still, this desert among oceans imagery carries deeper implications. Astronomers realised that studying voids could be just as important as studying clusters. Oceans tell you how fish swim, but deserts tell you how ecosystems break down. In the same way, clusters reveal how galaxies thrive, while voids reveal how matter, or the lack of it, shapes the universe's skeleton. Voids, by being so empty, amplify subtle effects of cosmic expansion. They're like clean laboratories where scientists can test how dark energy works, free from the noise of crowded regions. The Boötes Void, then, isn't just an oddity, it's a natural lab. Its size makes it easier to measure gravitational effects, to test whether the cosmic broth is behaving as expected. Some studies even suggest that voids might help explain why the universe appears to be expanding faster than expected, a puzzle tied to dark energy. In other words, this desert could be the key to understanding the ocean itself. And while we're on metaphors, consider this. Deserts on Earth are often beautiful precisely because they're empty. Towering dunes, endless horizons, skies so wide they almost hurt your eyes. The Boötes Void shares that stark beauty. It may lack galaxies, but it possesses scale, silence, and symmetry that no cluster could match. Sometimes, less really is more, at least when it comes to evoking awe. Of course your brain rebels a little. How can nothing be so important? Shouldn't we focus on the galaxies, the bright stuff? But that's like saying you can understand music by only listening to the notes and ignoring the rests. The silence between notes is what makes the melody. The emptiness between filaments is what makes the universe's structure meaningful. Without the Boötes Void, the surrounding galaxies wouldn't stand out. Now picture the cosmic web as a globe of froth, bubbles pressed together in a foamy mass. The Boötes Void is just one bubble, but because it's so large it sets the tone for the entire froth. Its desert defines the size of the ocean. Its silence defines the scale of the music. You, floating here, are caught in that paradox. You're measuring nothing, but discovering everything. And as the section winds down, here's one more playful comparison. If the universe were a loaf of raisin bread, the filaments and clusters would be the raisins. The Boötes Void? That's the giant bite where somebody ate all the raisins and left you with plain dough. Sure, it's still bread, but you can't help feeling a little cheated. Yet, as you hover, you realise that even the plain dough has a role to play. Without it, there'd be no loaf at all. The desert needs the ocean, the void needs the galaxies. Together they weave the tapestry of the cosmos, and you, small as you are, get to glimpse both sides, the fullness and the emptiness, the feast and the famine. You float at the boundary of the void, marvelling at its desert-like silence, when another question begins to nag. What was it like for the scientists who first uncovered this abyss? Discoveries aren't made in a vacuum. Well, except in this case, where the discovery literally was a vacuum of galaxies. But even so, behind every cosmic revelation are humans with coffee mugs, deadlines, and the occasional spilled sandwich. The Boötes Void might feel like timeless emptiness to you, but in the early 1980s it was brand new, and reactions to it range from awe to skepticism to outright denial. Picture the scene. The University of Michigan, 1981. Astronomer Robert Kirshner and his colleagues are poring over their galaxy redshift survey. Each point on their charts is supposed to represent a galaxy's distance, a neat dot on a sprawling three-dimensional map. Normally, those dots sprinkle across the page like someone had gone wild with a pepper shaker, but here, in the region of the Boötes constellation, the shaker seems to have run dry. The paper is nearly blank. Their first reaction: caution. Scientists are trained to mistrust surprises. A void this large, this empty, was almost too much to believe. Maybe the telescope had glitched. Maybe their survey missed fainter galaxies. Maybe, in the cruelest twist, someone had simply forgotten to point the instrument at that patch of sky. Imagine being the grad student in charge of that section. Your stomach would drop like you just deleted the group project the night before it was due. Here's your mainstream historical fact. When the discovery was first announced at astronomy conferences, many colleagues were skeptical. The largest known voids at that time spanned tens of millions of light years, not hundreds. To suddenly leap to 330 million light years sounded reckless. Some even whispered that Kirshner's team had exaggerated, chasing headlines more than data. And here's a quirky tidbit. In one retelling, a rival astronomer joked that the void was just the part of the sky where Michigan didn't have enough money for telescope time. A dig both at the emptiness and at the eternal reality of research budgets. Academia, where even the cosmic abyss isn't safe from funding jokes. Historians still argue whether the initial resistance came from genuine scientific skepticism or from plain old academic rivalry. Some accounts suggest that older astronomers steeped in models of a smoother universe couldn't stomach such a huge irregularity. Others think the skepticism was healthy. After all, science only works if new claims are rigorously tested. Either way, the void wasn't embraced immediately. It had to earn its place in cosmic cartography. Imagine yourself as a young astronomer in that moment. You've worked years on painstaking surveys, nights spent staring through telescopes, fingers numb from shuffling stacks of data cards, and then, when you present your big finding, half the room frowns, arms crossed, muttering that it can't be real. Do you feel deflated, defensive, or secretly thrilled that you've found something so bold it forces everyone else to argue about it? Meanwhile, the newspapers caught wind. Reporters loved the phrase "hole in the universe." It sounded dramatic, almost scandalous, like space had developed a dangerous leak. For the public, the reaction was less skepticism and more awe. Headlines blared about a region so vast and empty it dwarfed imagination. Of course, some readers took it literally, picturing a spherical gap like a missing puzzle piece, as if galaxies had been vacuumed up by a giant celestial Roomba. Science communicators had to scramble to explain that no, the void wasn't an actual hole in the fabric of space, just a region with unusually few galaxies. Still, the shock lingered. Up until then, most cosmologists imagined the universe's structure as fairly uniform on the larger scales. Sure, galaxies clustered, but given enough distance, everything should even out. The Boötes Void laughed in the face of that neatness. It said, guess what, the universe has wild mood swings. Some places are crammed, others are barren. That realization forced scientists to rethink their assumptions about cosmic structure. You drift closer, picturing the debates. Some astronomers argued that the void was a statistical fluke, an unlucky roll of the cosmic dice. Others insisted it proved that our theories about galaxy formation were incomplete. For months, papers bounced back and forth, each new survey trying to poke holes, or rather poke galaxies, into the emptiness. A joke to lighten the scene. One astronomer quipped that maybe the void was just the universe's way of giving introverted galaxies some personal space. Look, they imagined a spiral galaxy saying, I don't want to be part of your busy cluster, I just need a few 100 million light years to myself. Honestly? Relatable? But as the data piled up, skepticism began to soften. By the late 1980s, improved surveys confirmed the void's size and sparsity. The Great Wall was discovered around the same time, proving that the universe really did build absurdly large structures. Slowly, reluctantly, the Boötes Void went from impossible to proven fact. Its very existence became a cornerstone of large-scale cosmology. From your perspective, the drama is almost funny. Scientists, just like everyone else, can be shocked by surprise. They live in a universe where numbers stretch to billions, where light takes eons to cross space, and yet even they can blink at something so big and mutter, nah, that can't be right. The Boötes Void wasn't just an astronomical discovery, it was a test of human imagination. And then came the cultural reactions outside academia. Sci-fi writers pounced on the idea. Conspiracy theorists claimed the void hid secret civilizations or cosmic weapons. Some even speculated it was evidence of a simulation glitch, the universe's equivalent of a video game rendering error. The public, unburdened by peer review, embraced the weirdness wholeheartedly. The Boötes Void became a stage for imagination, both scientific and fanciful. But step back into 1981 for a moment. Picture the room when Kirshner's team first unveiled their maps. Silence, then murmurs. People leaning over to their colleagues, whispering, that can't be right. A few brave souls nodding, intrigued, others shaking their heads. This is how science digests the impossible, slowly, with debate and doubt, before finally conceding when the evidence refuses to vanish. The first reactions to the Boötes Void remind you of a larger truth. Humans are uncomfortable with nothingness. We want fullness, patterns, galaxies sprinkled evenly like sugar on cereal. When faced with emptiness, cosmic or personal, we fidget, invent explanations, or dismiss it altogether. Yet emptiness is just as real, just as defining as the stars themselves. And so, here you float centuries later, revisiting that first shock. The void is no longer contested, it's a textbook fact. But imagine, just for fun, being the one to discover it yourself. Imagine the jolt in your chest as you realise the map has a hole, a gap so enormous it swallows your sense of scale. You'd probably laugh, then panic, then laugh again, because sometimes the only response to the universe's absurdity is a nervous chuckle. You drift deeper into the Boötes Void, braced for nothingness, and then, there it is, a faint smudge. So delicate you almost dismiss it as a trick of the eye. Another just off to the side, then a third far away, pulsing faintly like the last street lamp on a long dark road. Against the sheer emptiness of the void, these galaxies seem absurdly fragile, like candles flickering in a cathedral that could swallow them whole. For all its reputation as the Great Nothing, the Boötes Void isn't completely empty. A few galaxies do live here, scattered like lost wanderers across an ocean of darkness. They're lonely outposts, hundreds of millions of light years from bustling clusters, marooned in the silence. Astronomers sometimes call them field galaxies, meaning they exist outside the usual crowded neighbourhoods. But calling them field galaxies feels almost too optimistic. Fields, at least, have grass. Here, the soil is black vacuum. Here's your mainstream historical fact. Surveys in the late 1980s and 1990s revealed roughly 60 galaxies inside the Boötes Void, far fewer than the thousands expected, but not absolute emptiness. Later, deeper surveys bumped the number up slightly. Today, estimates hover in the low hundreds. Still, for a volume this enormous, the population density is microscopic. And here's your quirky tidbit. One of the most unusual galaxies discovered in the void, named Void Galaxy 2, is a spiral galaxy with surprisingly active star formation, even though it's stranded without nearby neighbours. Astronomers joked that it's like a kid throwing a party all by themselves, blasting music even though no one else is around to hear it. Historians still argue whether these lonely galaxies formed in place, from tiny pockets of gas that just happened to collapse, or whether they were ejected into the void by gravitational tides. Did they grow up here, or are they cosmic exiles, banished from the bustling galactic cities on the void's rim? The debate lingers, unresolved. You imagine yourself living inside one of these galaxies. Night after night you look up at the sky, where you expect thousands of smears of distant galaxies. You see nothing. Maybe a faint neighbour glimmering in the farthest corner, but otherwise your universe feels claustrophobic, smothered in emptiness. Your philosophers might declare that the cosmos is barren, that your world is the only island in existence, and with no evidence to the contrary you'd believe them. For a moment, you let that loneliness sink in. On Earth, we worry about whether life exists elsewhere, and already the silence can feel heavy. But imagine if we had grown up in the Boötes Void. Our telescopes would never have glimpsed the Andromeda Galaxy, the Whirlpool, or the Sombrero. No Hubble Deep Field packed with thousands of galaxies, no cosmic web glowing like fireflies, just endless dark. Our species might never have dreamed beyond its own star system. A joke to soften the gloom, the galaxies inside the Boötes Void must be the ultimate introverts. No, thanks, I'll just orbit out here by myself. Too many neighbours make me spiral. But in truth, these stragglers are treasures. Each void galaxy provides a rare chance to study how isolation shapes evolution. Normally, galaxies interact constantly, merging, colliding, stripping gas from one another. In voids, those interactions are rare. The galaxies grow slowly, sheltered from cosmic drama. Some retain more gas than expected, giving them a bluish hue from ongoing star formation. Others remain oddly small and simple, like time capsules preserving conditions from billions of years ago. Astronomers, with their penchant for poetic understatement, describe void galaxies as laboratories of isolation. You prefer to think of them as hermits, quiet, stubborn, and a little eccentric. While galaxies and clusters gossip and brawl, these ones tend their stars in solitude, occasionally sending faint beams of light into the abyss, hoping someone somewhere notices. The numbers tell the stark story. Inside the Boötes Void, the density of galaxies is about 1/10, or less, of the cosmic average. If you lived in such a galaxy and pointed your telescope outward, you might have to search across millions of light years just to spot a single neighbour. On Earth, we can step outside and see Andromeda with the naked eye. For void dwellers, Andromeda's equivalent might be too faint to see even with their best technology. Their night skies would feel heartbreakingly empty. And that emptiness shapes more than just astronomy. It shapes imagination. Would a civilization born in the void ever develop a sense of cosmic connection? Or would they resign themselves to the belief that the stars overhead are the only stars there are? The Boötes Void is a scientific discovery, yes, but it's also a thought experiment about loneliness. Here's a vivid image for you. Imagine a dark desert, flat for miles, with only one or two huts scattered across the horizon. No cities, no roads, no flicker of other fires. That's what the void galaxies are like, lone huts in a desert night. You can't help but want to knock on their doors and ask how they manage. Of course, scientists don't just wax poetic, they crunch numbers. They classify void galaxies by type, compare them to galaxies and clusters, and model their growth. Some studies suggest that void galaxies may be younger, forming stars later than their crowded cousins. Others propose that they evolved differently because they are untouched by galactic cannibalism. Whatever the details, they're fascinating counterexamples, proving that the universe doesn't follow a single script. And then there's the eerie thought, what if life exists in one of these void galaxies? Intelligent beings, marooned in darkness, convinced they're alone in the universe. they'd never guess that beyond their bubble lies a bustling cosmos. The irony is almost cruel. We, fortunate enough to live in a crowded galactic neighbourhood, still feel cosmic loneliness. For them, loneliness would be reality itself, a joke to lighten that sting. Imagine the first Void astronomer telling their people, "I have discovered another galaxy," and the whole civilization throws a parade, only to realise it's still 200 million light-years away. Talk about long-distance relationships. And yet, you find beauty here. The Void galaxies glow like stubborn survivors, holding their ground in a place designed to erase them. They're fragile, yes, but also resilient, tiny protests against the tyranny of emptiness. Each one is proof that even in the bleakest conditions, light finds a way to exist. As you float past another faint spiral, you realise the Boötes Void isn't absolute silence. It's more like a whisper, faint but insistent. Those few galaxies are saying, "We're still here," and maybe, just maybe, that's enough. You drift away from those lonely galaxies, and your mind turns not to science, but to stories. Because the moment the Boötes Void escaped the walls of academia in the 1980s, it stopped being just a scientific curiosity. It became cultural fuel. Reporters called it the Great Nothing. Writers saw in it a ready-made metaphor. Conspiracy theorists and dreamers alike rushed to fill the silence with speculation. Humans can't stand a vacuum, not even in imagination. We pour meaning into emptiness like water into a jar. The first cultural ripples came in the newspapers. The phrase "hole in the universe" popped up everywhere, catchy and terrifying in equal measure. Readers conjured images of space literally torn open, a cosmic wound in the fabric of reality. Some people thought it was a black hole. Understandable confusion. After all, both involved nothing. While others pictured it as a portal to another universe, a kind of cosmic backdoor left ajar. Science journalists had to clarify repeatedly that no, the void wasn't sucking things in, and no, we weren't about to fall into it. Still, the drama stuck. Here's your mainstream historical fact. The Boötes Void got its nickname, the Great Nothing, almost immediately after its discovery in 1981, and the press latched onto it with delight. Unlike dense jargon like spherical underdensity, Great Nothing had the ring of legend. It was the kind of phrase that begged for campfire retellings and late-night debates. And here's your quirky tidbit. In one issue of Sky and Telescope magazine from the early 1980s, a reader's letter playfully suggested that the void must be where God forgot to sprinkle the stars. It was tongue-in-cheek, but it captured a feeling many had, that the void was less a physical phenomenon and more like a cosmic oversight, an unfinished part of the painting. Historians still argue whether the Boötes Void's public impact helped or hindered science. On one hand, catchy nicknames like Great Nothing drew attention to cosmology. On the other, they encouraged wild misconceptions, people mistaking voids for black holes or assuming the universe was literally collapsing. The tension between accuracy and wonder has always haunted science communication. From your vantage point, though, the cultural reaction feels almost inevitable. Humans have always filled the sky with meaning. Ancient Greeks saw constellations, medieval scholars saw heavens of divine order. In the modern age, when the cosmos revealed itself as strange and empty, we filled it with new stories, simulation glitches, alien megastructures, end-of-the-world metaphors. The Boötes Void arrived ready-made to serve as a canvas for our anxieties and imaginations. Science fiction, predictably, embraced it. Writers began slipping voids into their stories, sometimes literally, as gaping holes in space where physics unravelled, sometimes metaphorically, as settings for exile or cosmic loneliness. The void was less a place, and more a mood, the eerie quiet between stars, the reminder that not all of the universe is welcoming. In one novel, the void was portrayed as a scar left by a long-gone alien war. In another, it was a hiding place for civilizations advanced enough to retreat from the rest of the cosmos. A little joke to lighten the scene: if you're a sci-fi author and you don't use a gigantic hole in space as a plot point, are you even trying? But the void didn't just inspire writers, it inspired conspiracy theorists too. The 1980s were fertile ground for speculation about aliens, UFOs, and hidden truths. For some, the Boötes Void was obvious evidence that something had erased galaxies. Maybe aliens harvested entire civilizations. Maybe it was the firing range of intergalactic weapons. Maybe, whispered the bolder voices, it was proof that we're living in a simulation and someone simply forgot to render that section of the universe. The void wasn't emptiness, it was a glitch. And while scientists rolled their eyes, you can see why the theory stuck. The Boötes Void isn't just empty, it's aggressively empty. It feels intentional, like someone carved it out. When you stare into it long enough, your brain can't help but search for narrative. Surely something must explain this desert among oceans. Meanwhile, artists and philosophers began to use the void as metaphor. Painters imagined great black circles on canvases, suggesting both awe and dread. Poets used the great nothing as shorthand for existential loneliness, the human sense of being small in a vast, uncaring cosmos. For some, the void was terrifying. For others, it was strangely comforting, a reminder that emptiness exists alongside fullness, that the universe holds space for silence as well as sound. Think of how we use metaphors of emptiness in everyday language. A hole in my heart, a void in my life. The Boötes Void gave those phrases cosmic weight. Here was a literal void, writ across the sky, validating our sense that emptiness is part of the human condition. It's not just you, even the universe has gaps. A playful comparison. If the Milky Way is the universe's Spotify playlist, then the Boötes Void is that awkward 3-minute silence where the Wi-Fi cuts out. Annoying, unsettling, but also a reminder that even infinity has pauses, and the more people talked about it, the more the void seeped into pop culture. Documentaries gave it ominous soundtracks. Sci-fi shows hinted at the great nothing as a place beyond known space. Internet forums spun endless threads speculating about what could live inside. The void wasn't just an astronomical feature anymore, it was a cultural character, a role in our collective imagination. Of course, not everyone reacted with dread. Some saw the void as proof of cosmic balance. Without emptiness, one philosopher wrote, there would be no room for form. In this view, the Boötes Void wasn't a mistake, but a masterpiece, negative space on the grandest canvas. Just as silence makes music possible, the void makes the cosmic web legible, and as you float here, considering both the skeptics and the dreamers, you realize the void's cultural impact mirrors our own divided reactions to emptiness. Some people fear it, others find peace in it, some fill it with stories, others insist on keeping it bare. The Boötes Void is a mirror reflecting our hopes, our anxieties, and our need to find meaning in the gaps. You smile, imagining a 1980s dinner party conversation. Did you hear about the hole in the universe? Someone says over casserole. They say it's 300 million light years wide, the guests murmur, half impressed, half bewildered. Someone jokes, well, I guess we finally found where my missing socks go. Laughter, then silence, as the enormity sinks in. Even in casual settings, the void invites humour to soften dread. That's the funny thing about cultural reactions. Science tells us the void is just a region with fewer galaxies. Culture tells us it's a metaphor, a glitch, a mystery, a mirror. Both are true in their own ways. The void exists out there, objectively, and it exists in here, subjectively, as part of our imagination. And maybe that's the Boötes Void's greatest trick. By being so absurdly empty, it demands to be filled, whether with galaxies, with stories, or with meaning. It refuses to remain just nothing. It becomes something, precisely because we can't stop thinking about it. You've lingered long enough among the cultural echoes of the great nothing, and now your thoughts drift back to physics. Culture gives us metaphors, but gravity gives us the mechanics. After all, if the universe is a grand dance of attraction, then a place like the Boötes Void feels like an awkward dancer who never steps onto the floor. The handshakes of gravity, those invisible pulls between galaxies, are conspicuously absent here. And that absence is more than eerie, it's instructive. Normally galaxies cluster because gravity never misses a chance to introduce two massive objects. Every galaxy, no matter how lonely, feels the subtle tug of its neighbours, forming larger structures over billions of years. Picture it like a crowded party. People drift toward conversations, clusters form around food tables, and eventually no one is standing completely alone. But in the Boötes Void, the gravitational handshakes are weak, few, and far between. The party's food table is empty, and everyone has wandered off to the edges. Here's your mainstream historical fact. By the 1990s, cosmologists had incorporated voids like Boötes into large-scale simulations of the universe's structure. These models, based on the laws of gravity and cosmic expansion, showed that voids form naturally as matter flows toward denser regions, leaving hollows behind. In other words, the void isn't broken physics, it's physics playing out over unimaginable scales. And here's your quirky tidbit. Some researchers playfully described voids as cosmic antisocial zones. One paper even nicknamed them wallflowers of the universe. Imagine a spiral galaxy with a shy expression, leaning against the cosmic wall while everyone else twirls in crowded clusters. Even scientists, it seems, can't resist anthropomorphizing their equations. Historians still argue whether voids like Boötes expand because of internal dynamics, matter streaming outward, or because they're passively stretched by the expansion of the universe as a whole. Do voids actively push galaxies away, like repelling magnets, or do they simply grow because the space between galaxies grows? The jury is out, and the debate shapes how we model cosmic evolution. For you, though, the feeling is simpler. You float inside the void, and it's not just dark, it's light on pull. Out in a galaxy cluster, you'd feel the constant tug of surrounding masses, a gravitational choreography drawing you into the swirl. Here, the silence isn't just visual, it's physical. The pull is faint, indecisive, like a handshake that never quite tightens. To imagine it, think of standing between two towns. One side is packed with skyscrapers, buzzing with activity, its gravitational handshake firm and insistent. The other side is empty prairie, stretching for miles. Naturally, you drift toward the city. That's what galaxies do at the void's edge. They feel the stronger handshake of filaments and clusters, and they migrate outward, leaving the hollow behind. The strangest part? Gravity still exists inside the void, but it's diffuse, subtle, stretched thin like butter over too much bread. If you placed a marble here, it would still roll downhill, but the hills are shallow, barely perceptible. It's like playing with magnets across a football field. The pull is there, but it's faint enough to forget. Here comes a little joke. If gravity inside the Boötes Void were a friend, it'd be the one who says, "Yeah, let's hang out sometime," but never actually texts you back. Astronomers study these weak gravitational environments precisely because they're unusual. In clusters, galaxies collide and merge, star formation rises and falls chaotically. In voids, galaxies evolve more slowly, free from the constant handshakes of neighbours. They're like control groups in an experiment, quiet labs where scientists can observe what happens when gravity leaves things mostly alone. And yet, emptiness has weight. Even the void bends space-time, albeit gently. Light passing through it takes slightly longer to travel, a subtle effect known as the integrated Sachs-Wolf effect. By studying how cosmic microwave background radiation shifts when it crosses a void, scientists hope to learn more about dark energy, the mysterious force accelerating the universe's expansion. In that sense, the Boötes Void isn't just a passive gap, it's an active clue, a whisper about the deepest physics at play. Imagine for a moment a beam of light crossing the void. It begins its journey on the bright rim, where galaxies cluster like lanterns. Then it enters the hollow. The tug of gravity weakens. Space feels smoother, less curved. The beam coasts unbothered, like a car rolling through an empty highway with no traffic lights. Millions of years later, it emerges on the far side where gravity's handshake grows firm again. That tiny difference in its path is detectable, proof that even nothing leaves fingerprints. And here's a thought experiment. What if Earth were inside the Boötes Void? Our night sky would still show stars. Those belong to our Milky Way, but beyond them, the faint wash of other galaxies would vanish. No Andromeda climbing the horizon. No fuzzy smudges marking distant spirals. The Hubble Deep Field would be almost blank. We'd think gravity was strangely quiet, our corner of the cosmos suspiciously tame, and we might assume that's how the entire universe worked, never suspecting that beyond our void, gravity shakes hands with gusto. It's humbling to realize how much our cosmic address shapes our knowledge. We live on the outskirts of a cluster, in a filament-rich region surrounded by galaxies that keep us company. From here, we see the fullness. From inside Boötes, you'd see only the quiet. Gravity, or its lack, writes the script of what you think reality is. A small joke to lighten the thought. Maybe that's why no civilizations from the Boötes Void have visited us. They started driving millions of years ago but keep stalling, because gravity inside the void is basically on airplane mode. Scientists often describe the cosmic web as a balance between voids and filaments. Without voids, filaments wouldn't stand out. Without filaments, voids wouldn't grow. It's a push and pull dance. Gravity builds walls, and in building walls, it leaves behind hollows. The Boötes Void is less a mistake and more a consequence, a reminder that nature rarely distributes anything evenly. And so you float, arms wide, feeling the faint tug from distant clusters on all sides. The handshake is absent, yes, but its absence is a clue. Gravity defines not just what exists, but what doesn't. The Boötes Void isn't empty of meaning. It's overflowing with it. It tells us that even silence in the universe has a rhythm, and even nothingness is worth measuring. You hang suspended in the middle of the Boötes Void, letting the absence of gravity's handshake settle around you, and now the obvious question drifts in. Why do voids form at all? If the universe started from one hot, dense soup of matter and energy, why didn't galaxies spread evenly, like sprinkles shaken across frosting? Why do we get this cosmic sponge, foamy with filaments riddled with empty bubbles, instead of a neat, uniform scatter? The answer, as usual in cosmology, starts at the very beginning. The universe wasn't born perfectly smooth. After the Big Bang, the infant cosmos was filled with tiny fluctuations, slight overdensities and underdensities in the sea of matter and radiation. They were almost imperceptible, 1 part in 100,000, but gravity is a ruthless amplifier. Where matter was slightly denser, gravity pulled more matter in, and clumps grew. Where matter was slightly thinner, gravity pulled less, and the hollows stretched emptier over time. Think of baking bread. The dough starts mostly uniform, but tiny air bubbles form as yeast ferments. Some bubbles grow larger than others, leaving pockets of emptiness surrounded by denser bread. That's the cosmic web in a nutshell, except instead of yeast, we had quantum fluctuations. Instead of bread, we had billions of galaxies. And instead of a few hours in the oven, we had 13.8 billion years of cosmic expansion. Here's your mainstream historical fact. The cosmic microwave background, discovered in 1965 and mapped in exquisite detail by missions like COBE, Doppelmap and Planck, shows those early fluctuations. The faint hot and cold patches in the background radiation are the seeds of today's cosmic structure. Regions that were slightly denser became galaxy clusters. Regions slightly emptier became voids. The Boötes Void is simply one of those emptier patches grown to absurd scale. And here's your quirky tidbit. One cosmologist once joked that the universe is basically the world's largest bubble bath, only without the rubber duck. Another quipped that if you ever feel unevenly distributed in life, just remember that the universe itself started lumpy, comforting in a chaotic way. Historians still argue whether voids form purely from those early fluctuations or whether later processes, like dark energy and galaxy feedback, play bigger roles. Did the emptiness come baked in, or did galaxies themselves help carve the voids by tugging matter toward filaments? The debate continues, with simulations offering competing answers. But zooming out, the big picture is clear. Voids are not mistakes. They're inevitable byproducts of the universe's architecture. If you pour matter into a universe, and let gravity and expansion run the show, you don't get uniformity, you get contrast. Galaxies clump into walls, voids emerge between them. The Boötes Void isn't an exception, it's just an extreme example of a rule. Now put yourself in the role of cosmic architect. Imagine laying out a three-dimensional web across billions of light years. You tug a little more here, a little less there. Soon, filaments crisscross like highways. Clusters glow at intersections, and in between, vast empty suburbs stretch out. The design isn't deliberate, but it looks almost intentional, like the foam on cappuccino or the veins of marble. Nature has an aesthetic streak. To make this more tangible, imagine two marbles on a rubber sheet. They roll toward each other, pulled by gravity. Now add more marbles, and soon they're all clumping into groups, leaving open spaces where none happen to land. Scale that up to galaxies, and the voids are just the open spaces between marbles. The Boötes Void is what happens when you zoom in on one of those gaps and realize, whoa, it's bigger than your whole hometown, your whole planet, your whole imagination. And here's a joke to lighten the mood. If the universe were a high school cafeteria, the clusters are the popular kids crammed around one table, while the void is the corner where nobody sits. Not because the table's broken, but because gravity didn't hand out enough social invitations. What fascinates astronomers is how voids evolve over time. Simulations suggest they don't just sit there passively. As galaxies migrate toward filaments, voids expand, merging with one another like soap bubbles combining into bigger bubbles. That means the Boötes Void, vast as it is, might once have been smaller, stitched together from overlapping emptier regions. Over billions of years, the hollows grew until they became a single cavernous expanse. This dynamic nature makes voids powerful tools for cosmology. By studying their growth, scientists test models of dark energy, the mysterious pressure accelerating cosmic expansion. If voids grow faster or slower than expected, it could hint at new physics. In that sense, the Boötes Void isn't just a curiosity, it's a measuring stick for the fate of the cosmos. Now imagine you're floating inside, watching the process unfold in fast forward. Over millions of years, the few galaxies inside drift slowly outward, inching toward the filaments. The hollow expands, swallowing smaller pockets of emptiness. You feel the universe breathe, not in seconds but in eons, inhaling galaxies into clusters, exhaling emptiness into voids. The dance is both chaotic and elegant, a playful metaphor. If clusters are cities and filaments are highways, then voids are the farmlands being abandoned as everyone moves to urban centres. The countryside empties out, and what's left behind is silence, broken only by the occasional lonely farmhouse galaxy. But even within this emptiness, there's beauty in the balance. Without voids, the universe would look homogeneous, dull, almost sterile. With them, it has texture, contrast, drama. Voids are the pauses in the music, the blank space on the canvas, the silence that lets you hear the sound. The Boötes Void, terrifyingly large though it may be, is also an artist's flourish, a reminder that even nothing can have form. And perhaps that's the strangest lesson. The universe didn't need to make voids so grand, yet it did. Maybe it couldn't help itself. Maybe gravity, left unchecked, always paints in contrasts. Whatever the case, you drift here knowing that emptiness isn't an error. It's a feature, a deliberate absence as important as presence. You've just finished wrapping your head around why voids exist at all, those cosmic bubble bath froths of structure, and now you find yourself wondering, do these enormous pockets of nothing actually affect the universe on a larger scale? The short answer, yes. The long answer, oh, very much yes, especially when you bring in two of the strangest concepts in modern cosmology, cold spots and dark energy. Let's start with cold spots, because the word already feels ominous. In the mid-1990s, astronomers mapping the cosmic microwave background, the faint afterglow of the Big Bang, noticed that the sky isn't perfectly uniform. It's mostly smooth, sure, but it's speckled with faint hot and cold patches. Those patches are relics of the early universe, the fingerprints of the tiny fluctuations that seeded galaxies and voids. But one particular cold spot discovered in data from the UMAP satellite in 2004 has stubbornly refused to make sense. It's bigger, colder, and weirder than models predict. Here's your mainstream historical fact. In 2007, a team of astronomers suggested that this CMB cold spot might actually line up with a gigantic void in the constellation Eridanus. The idea was that light passing through a void loses energy in a subtle process called the integrated Sachs-Wolf effect, making the spot appear colder. Suddenly, voids weren't just passive emptiness. They were cosmic fingerprints potentially visible across the whole sky. And here's your quirky tidbit. Some tabloids immediately ran with the idea that the cold spot was proof of a parallel universe bumping into ours. Astronomers discover brews from another cosmos, blared one headline. That wasn't what the scientists meant, of course, but the story had legs. Because let's be honest, brews from another cosmos sounds way cooler than subtle statistical anomaly in microwave background radiation. Historians still argue whether the cold spot really comes from a void or whether it's just a fluke in the data. Some studies find correlations between voids and cold spots. Others say the effect is too weak to explain the anomaly. The debate remains lively, because it cuts straight into the heart of cosmology. Are our models complete, Or is the universe whispering that we've missed something? You hover inside the Boötes Void, imagining photons of light streaming past. Each one has been travelling for billions of years, but as it crosses the hollow, the gravitational tug is weaker. It's as if the photon briefly coasts downhill, then uphill again, but the climb out costs it just a little more energy than the descent gave. By the time it emerges, it's slightly stretched, slightly redder, slightly colder. A minuscule effect, but across billions of light years, enough to show up in our maps of the sky. And that brings you to the elephant in the cosmos: dark energy. Discovered in the late 1990s, dark energy is the mysterious force causing the expansion of the universe to accelerate. Not just expand, accelerate. Galaxies aren't just drifting apart, they're speeding up, as if some invisible hand is pushing them outward. Scientists don't know what dark energy is. They only know it makes up about 70% of the universe and behaves like a repulsive pressure. Here's where voids like Boötes get fascinating. Because they're underdense, they expand faster than average. Think of it like this. Crowded regions of the universe, clusters and filaments, are weighed down by their own gravity. They resist expansion. Voids, by contrast, are lightweights. With less matter to hold them together, they stretch more easily, like soap bubbles swelling as air is blown in. That makes them sensitive indicators of dark energy's behaviour. To visualise it, picture two balloons. One is half filled with sand, a cluster, the other is empty, a void. Now, blow into both. The sandy balloon resists, bulging only a little. The empty balloon swells dramatically. That's the difference dark energy makes across cosmic landscapes. Here comes a light joke. If you want to know how dark energy works, don't ask a cluster, it's too weighed down. Ask a void. It's been stretching out in yoga class for billions of years. Scientists today use surveys of cosmic voids to test models of dark energy. They measure how fast voids grow, how round or irregular they are, and how light passing through them shifts. The Boötes Void, being one of the largest and most extreme, is a favourite test case. Its sheer scale makes it like a giant neon sign saying, "Look here." This is where the weird physics shows itself. Historians still argue whether voids can truly constrain dark energy better than clusters. Some claim voids are too messy, too irregular. Others insist that their emptiness makes them perfect laboratories. The debate is ongoing, and meanwhile telescopes keep scanning the sky, cataloguing void after void. Each new map is another data point in the puzzle of why the universe is accelerating at all. Now picture yourself drifting through the Boötes Void, but this time, instead of loneliness, you feel expansion pressing on all sides. The hollow is growing, very slowly, imperceptibly to you, but measurable over billions of years, galaxies on the edge inch farther apart. The void swells like dough rising in the oven. It's a quiet growth, but relentless. And you realise this emptiness is alive, in its own way, shaped by forces you can't see but can measure. That's the irony of voids. They look like nothing, but they're laboratories of everything. They reveal how light bends, how gravity pulls, how dark energy pushes. They're silent, but they speak volumes about the fate of the cosmos. And here's another thought experiment. Imagine if dark energy behaved differently, if it were stronger or weaker. The Boötes Void might have grown larger or smaller, colder or warmer. In another universe, it might not exist at all. Its presence, just as it is, tells us something profound about the balance of forces shaping reality. A joke to close this thought. Scientists spend decades trying to understand dark energy, but maybe the Boötes Void already has the answer. It's just sitting there, arms crossed, refusing to explain itself, the ultimate cosmic introvert. And so you float, surrounded by coldness and emptiness, realizing that even here, in the heart of nothing, forces are at work, sculpting the universe. The Boötes Void isn't just an empty bubble, it's a cosmic magnifying glass, revealing the subtle fingerprints of dark energy, the faint chill of cold spots, and the restless expansion of reality itself. You've been wandering through the Boötes Void long enough now that your mind starts blending terms. It's dark, it's empty, it's unfathomably huge. So is this like a black hole? People ask that question all the time, and honestly, you can't blame them. Void and hole sound like synonyms, and both conjure images of cosmic nothingness. But the truth is, voids and black holes are about as different as deserts and whirlpools. Both involve absence, but in opposite ways. Let's set the record straight. A black hole is a region where gravity is so strong that nothing, not even light, can escape. It's the ultimate gravitational handshake, crushing matter into a singularity. The Boötes Void, by contrast, is a place where gravity is weak, where matter is sparse, where galaxies drift apart instead of being pulled inward. One is extreme compression, the other is extreme dilution. They're mirror images on the cosmic spectrum. Here's your mainstream historical fact. Black holes were first seriously described by physicist John Michell in 1784 and later formalized by Einstein's general relativity in 1915, with the first physical candidates identified in the 1960s. By the time the Boötes Void was discovered in 1981, black holes were already media darlings, mysterious, terrifying, glamorous in a way that empty space could never quite compete with. This is why people constantly confuse the two. And here's your quirky tidbit. In the 1980s, a few news outlets initially misreported the Boötes Void as a giant black hole, causing at least one poor schoolteacher to field panicked questions from kids about whether Earth was going to be swallowed by it. Imagine trying to calm a room of 11-year-olds by saying, no, it's just a giant nothing. Comforting, right? Historians still argue whether public fascination with black holes actually slowed popular understanding of voids. Because black holes were already so ingrained in science fiction and pop culture, voids seemed boring by comparison. No spaghettification, no swirling accretion disks, no dramatic death rays, just a giant cosmic shrug. Only in recent decades have voids begun claiming their own spotlight in research and storytelling. From your perspective here in the void, the difference is visceral. In a black hole, you'd be ripped apart by tidal forces long before you crossed the event horizon. Here, by contrast, you could float comfortably forever. No danger, no pull, just nothing. A black hole is danger wrapped in mystery. A void is boredom stretched to infinity. But don't dismiss boredom too quickly. It's instructive. In the absence of drama, voids reveal the subtler dynamics of the universe, how dark energy accelerates expansion, how galaxies evolve without constant collisions, how emptiness itself sculpts the cosmic web. Black holes tell us about the extremes of gravity. Voids tell us about the extremes of absence. Together, they bracket the universe's possibilities. Here's a visualization. Imagine the cosmos as a landscape. Black holes are deep sinkholes where everything tumbles inward. Voids are wide plains where everything drifts outward. The two coexist, shaping the topography of space-time, where one grips tight, the other lets go. And here's a playful joke. If black holes are cosmic vacuum cleaners, voids are cosmic do not disturb signs. One sucks everything in, the other shrugs and says, "Nah, I'm good." Of course, scientists study both with equal seriousness. Black holes test general relativity at its limits. Voids test cosmology on the larger scales. You need both to understand the universe fully. Imagine trying to learn music by only listening to the highest notes or only the lowest bass. To hear the song, you need the full range. Yet the public imagination still leans toward black holes. Maybe it's the drama, maybe it's the terror, or maybe it's just that humans are wired to notice things that threaten us, not things that ignore us. Black holes eat stars, voids merely starve them. The first is a monster, the second is a famine. Which headline are you more likely to click on? But take a moment and appreciate the irony. Black holes, despite their terrifying reputations, are actually tiny on cosmic scales. The largest ones measure maybe a few hundred light years across. The Boötes Void? 330 million light years. In size alone, voids win hands down. If you want to be swallowed, sure, pick a black hole. But if you want to disappear into obscurity, the void has you covered. And then there's the philosophical angle. Black holes raise questions about death, endings, finality. Voids raise questions about absence, silence, and meaning. Which one feels scarier depends on your temperament. Do you fear the crushing embrace of gravity or the endless shrug of nothingness? Either way, the universe provides. Historians still argue whether the Boötes Void deserves its dramatic nickname. Some suggest calling it a super void to emphasize its scientific reality, rather than its theatrical emptiness. Others defend Great Nothing as a reminder that science is allowed to be poetic. After all, black holes aren't literally holes either. But the name stuck. Sometimes, catchy wins. Now picture yourself floating between the two extremes. On one side of your imagination, a black hole yawns, its event horizon shimmering, its pull irresistible. On the other side, the Boötes Void stretches soft and indifferent, no pull at all. You're balanced between being torn apart and being left completely alone. Which fate feels worse? Which feels more peaceful? A final joke to tie the bow: if black holes and voids ever dated, their relationship status would read, "It's complicated." One's clingy, the other's avoidant. Classic cosmic mismatch. And so you drift in the Boötes Void, finally clear on the difference. It's not a black hole. It won't swallow you. It won't stretch you into spaghetti. It will simply surround you, endless and patient, waiting for you to acknowledge that nothing is, in its own quiet way, something. You're floating in the Boötes Void, finally clear that it's not a black hole, when another thought hits. If this place is enormous, how does it compare with the other giants of the cosmos? Because one of the sneakiest tricks of astronomy is that biggest is always provisional. The moment you learn about one record breaker, the universe politely coughs and says, "Oh, you thought that was huge. Hold my quasar." The Boötes Void, stretching 330 million light-years across, is gargantuan. But it isn't the only contestant in the larger structure's Olympics. To understand its place, you have to zoom out and consider the broader cast: walls, filaments, superclusters, and even larger cosmic oddities that strain the limits of our theories. Here's your mainstream historical fact. In 1989, just a few years after the Boötes Void's discovery, astronomers Margaret Geller and John Huchra announced the CFA2 Great Wall, a sheet of galaxies more than 500 million light-years long. That discovery shocked the field. Up until then, the cosmological principle that the universe should look roughly the same at the larger scales was gospel. A wall 500 million light-years long didn't exactly scream homogeneity. The Boötes Void suddenly had a foil, where one was emptiness, the other was abundance. And here's your quirky tidbit. When the Great Wall was first mapped, one astronomer compared it to a gigantic slice of Swiss cheese, complete with voids as holes and filaments as the rind. Apparently, when faced with the universe's larger structures, scientists get hungry. Historians still argue whether these larger structures violate the cosmological principle or merely test its limits. Some claim that superclusters and walls are too big to be consistent with uniformity. Others argue that statistically such giants can still exist within a universe that is homogeneous on even grander scales. The debate continues, because every new survey seems to reveal something bigger than we expected. For you, though, this is less about statistics and more about sheer awe. You picture the universe not as empty space sprinkled with galaxies, but as a vast three-dimensional tapestry, woven with threads hundreds of millions of light-years long. The Boötes Void is one gaping hole in that tapestry. The Great Wall is one thick strand. Put them together, and you see the true scale of cosmic architecture. Absurd, almost comical in its hugeness. And then came even wilder discoveries. In 2003, astronomers identified the Sloan Great Wall, stretching 1.4 billion light-years. Later came the Hercules Corona Borealis Great Wall, proposed in 2013, at an eyebrow-raising 10 billion light-years long. So big it accounts for a tenth of the observable universe. To be fair, not everyone agrees that structure is real. Some say it's an illusion caused by sampling bias, but even so, the very possibility of a structure that size makes the Boötes Void look almost modest. Still, you shouldn't dismiss it. The Boötes Void holds a different kind of record. It's one of the emptiest regions ever found. A wall impresses by being crammed full. A void impresses by being stripped bare. Both are extremes, like the highest mountains and the deepest trenches of Earth. You need both to understand the planet's geography, and you need both to understand the universe's. Here's a playful metaphor. If the universe were a pizza, the Great Walls are the gooey strings of cheese stretching across the slice, the Boötes Void. That's the big bubble of air you bite into, hollow but still part of the crust. Neither is better. Together they make the meal. Now imagine drifting across these scales. First, you float through the Boötes Void, 330 million light-years of silence. Then you exit into the Sloan Great Wall, where galaxies blaze in sheets, packed so tightly your view looks like city lights from orbit. Then you zoom farther out into structures like Laniakea, the supercluster that includes our Milky Way. Suddenly, you realize the Boötes Void isn't an isolated curiosity, it's a stitch in a much bigger quilt, a hollow in a cathedral so vast your imagination keeps hitting its own ceiling. And here's a little joke to keep you grounded. If Earth were a marble, the Milky Way would be a city, the Laniakea supercluster would be a continent, and the Boötes Void would be that awkward empty lot where the city planner never built anything. Great location, zero amenities. The larger structures remind us that the universe is not polite in its proportions. It doesn't make things small and digestible. It makes them so big that human metaphors buckle under the weight. You can compare a galaxy to a city, but what do you compare a wall of galaxies to? What do you compare a void to? You end up with pizza, cheese, bubble baths, because that's all we have. Historians still argue whether our universe even has a maximum scale. Is there a point at which structures stop forming? Or will we keep discovering bigger and bigger walls and voids until our sense of largest collapses entirely? The cosmological principle insists there's a cutoff, that at some scale, everything evens out. But every time we think we've found it, a new structure stretches the boundary. The Boötes Void, in its way, was one of the first dominoes to fall in this chain of surprises. You lean back in your imaginary star cruiser and let the comparisons wash over you. Voids, walls, superclusters, sheets, bubbles. Together they form something both chaotic and orderly, like frost patterns on glass. The Boötes Void might not be the largest structure in the universe, but it's one of the most striking, precisely because its absence given form. It's the hollow note that makes the song resonate. And then comes the personal realization. No matter how big these structures are, your perspective will always be limited by where you stand. To an ant, a football field is infinite. To us, the Boötes Void is unthinkable. To the universe itself, maybe it's just another bubble in the froth. Scale isn't absolute, it's relative. The largest known structures aren't just astronomical curiosities, they're reminders of how tiny, and yet how capable of wonder, we really are. So, as you float at the boundary of the Boötes Void, comparing it to walls and filaments, you can't help but chuckle. It might not be the biggest kid on the cosmic playground anymore, but it's still the one that made us gasp first. And sometimes, being the first to shock humanity is more memorable than being the absolute largest. You've compared the Boötes Void with walls and filaments, marvelling at its place in the grand quilt of the universe. But now, let's do something reckless. Imagine travelling through it. Not just hovering on the edge, not just peeking in from afar, but actually making the crossing. Strap in. Though honestly, strap in is more for psychological comfort. Because in a void, there isn't much turbulence, just millions of light years of darkness stretched out in every direction. Your spaceship hums softly as you leave the rim. Behind you, the universe blazes with galaxies, filaments glowing like veins. Ahead of you, blackness. Not the cozy black of a clear Earth night dotted with stars. This is starker, lonelier, as if the lights have been turned off in the theatre and the curtain never rose. For a while, the view feels exciting, adventurous. You're a pioneer stepping into the unknown. But as the years, decades, centuries of travel mount, the emptiness starts to gnaw. Here's your mainstream historical fact. If you tried to cross the Boötes Void at the speed of light, the journey would take 330 million years. That's longer than the time since the first dinosaurs roamed Earth. To put it another way, if you left when the supercontinent Pangaea was forming, you'd still be en route today, waving sadly at all the extinct reptiles you passed on the way out. And here's your quirky tidbit. In the late 20th century, a group of amateur astronomers once joked that the only practical way to map the Boötes Void would be to install a Starbucks at the halfway point, just to give future spacefarers somewhere to stretch their legs. Imagine the marketing campaign. Now serving caramel lattes only 165 million light years away. Historians still argue whether such imaginative travel scenarios help or hinder public understanding. Some say it trivializes the vastness, making it sound like a road trip. Others argue that metaphors are the only way humans can begin to digest numbers this absurd. After all else, you don't really feel 330 million years. You feel the comparison. Dinosaurs, continents, a road trip with no pit stops. So let's picture the journey more closely. At first, you still see the filaments behind you, faint threads of galaxies twinkling on the horizon. But as you drift farther, those threads fade. You check your navigation screen, still hundreds of millions of light years to go. You pass one lonely galaxy, a dim spiral huddled against the dark. For a moment, relief washes over you. Finally, some company. But then it vanishes in the rear view, leaving you alone again. Silence closes in, thick as velvet. The human brain doesn't do well with nothingness. On Earth, even in deserts or oceans, there's always sound. Wind, waves, your own heartbeat. Here, this silence is absolute. No planets passing close by, no stars crowding the window, just black. Your thoughts grow louder than the cosmos itself. If this were a movie, you'd already be narrating a dramatic monologue about isolation. A light joke to break the tension. Halfway through the Boötes Void, you realise you forgot to pack snacks. Worst cosmic road trip ever. The scale continues to overwhelm. Imagine if each light year were just a single mile. Crossing the Boötes Void would still be like driving 330 million miles. That's more than 1,000 trips to the moon and back at the speed of a car. Even imagining such distances feels absurd. The void stretches not just across space but across imagination. And then there's the question of what you'd see out the window. In galaxy clusters, space looks crowded, stars packed close, glowing clouds of gas lighting the view. In the void, you'd see so few galaxies that the sky would almost resemble Earth's night sky. Sparse, underwhelming, deceptive. Without context, you might even think the void is normal. It's only when you realise what should be there, the thousands of missing galaxies, that the weight of the absence hits. Now, imagine reaching the halfway point. You've travelled for 165 million years at light speed. Behind you, galaxies are so distant they look like dust. Ahead, the far edge of the void is still invisible, still a dream. You're stranded in the middle of nowhere, the ultimate cosmic rest stop with no vending machines. Even if you shout, your voice can't carry across such distances. The silence feels eternal, and yet, oddly enough, there's beauty in it. Freed from the clutter of stars and galaxies, you see the blackness itself, smooth, uninterrupted, a canvas of perfect calm. It's almost meditative. Astronauts often talk about the overview effect, the profound shift in perspective when they see Earth from space. Travelling through the Boötes Void would be the overview effect magnified 1,000-fold. You wouldn't just see Earth's smallness, you'd feel the fragility of the entire cosmic web. Here's another playful joke. You finally reach the far edge of the void, and there's a sign that says, "Welcome to the universe. Thanks for visiting our emptiest attraction." But jokes aside, this thought experiment highlights something profound. The universe is stitched together not by fullness but by contrast. Travelling through the Boötes Void shows you absence in a way that standing in a galaxy never could. It forces you to reckon with the scale of silence, to see that nothing can be just as monumental as something. Historians still argue whether void travel scenarios are useful teaching tools. Some think they're too anthropocentric, projecting road trips onto cosmic distances. Others argue that imagination is the only vehicle humans have to traverse such scales. After all, you're not really travelling through the void right now. You're lying in bed, listening, and yet your mind has already crossed millions of light years. That alone is remarkable. And so the journey ends, not in exhaustion, but in perspective. You emerge from the Boötes Void onto the far side where galaxies blaze again in clusters and filaments. After so much silence, the sight feels overwhelming, like stepping out of a cave into sunlight. You understand the void better now, not just as a number, not just as a fact, but as a lived experience, if only in imagination. It's not just empty, it's emptiness that teaches. You've just emerged from the thought experiment of crossing the Boötes Void, and as the glow of galaxies at its far rim returns to your view, one lingering question tugs at you. Could life ever exist inside this emptiness? Not just stars and galaxies, but life as we imagine it. Planets with oceans, creatures looking up at the night sky, maybe even someone else wondering about the void in return. At first glance, the answer feels obvious. No way. After all, this place is underpopulated by galaxies, the raw ingredients of stars and planets. With only a fraction of the expected galaxies, the odds of forming habitable systems seem laughably small. But then you remember those stubborn galaxies you passed in Section 7. The lonely spirals glowing faintly in the dark, they exist. And where galaxies exist, stars can form. And where stars exist, planets can follow. And where planets exist, well, the door creaks open. Here's your mainstream historical fact. Astronomers have detected over 5,000 exoplanets in our own corner of the universe, most within a few thousand light years of Earth. Many orbit stars in environments not too different from what you'd find in void galaxies. Quiet, relatively isolated, free from the chaos of dense clusters. If planets can exist here, why not there? And here's your quirky tidbit. In 2015, a group of scientists playfully suggested that if civilizations did evolve inside void galaxies, they might be less prone to existential dread about cosmic loneliness, because for them, loneliness would be the default. In other words, no Fermi paradox, no frantic, "where is everybody?" Just a calm shrug. Obviously it's just us. Comfortably bleak or bleakly comfortable, depending on your mood. Historians still argue whether intelligent life needs a crowded environment like ours. Some say being in a filament-rich region increases chances of survival. More nearby galaxies means more chances for resource exchange, more starlight, more diversity. Others counter that crowded regions can also be dangerous, with supernovae and collisions more common. Voids, by being quiet, might actually protect fragile ecosystems. The debate lingers, unresolved. Imagine yourself as a creature born in a void galaxy. Your ancestors evolved around a small yellow star, orbiting a rocky planet with oceans and continents. For millennia, your people gazed upward, seeing only a sparse sky. They told myths about the empty heavens, imagined gods hiding in the black. Their astronomers eventually discovered faint smudges, distant galaxies barely visible, but concluded that the universe is almost entirely barren. The idea of a crowded cosmos never even occurred to them. From their perspective, Earth's night sky, with its sweep of the Milky Way, its neighbouring galaxies visible to the naked eye, would look absurdly luxurious, as if we live in a cosmic metropolis. For them, the void's silence would define reality. Their philosophies might be built not on yearning for neighbours, but on celebrating solitude. Perhaps their religions would describe creation not as a burst of light, but as a deliberate carving of emptiness. A joke to lighten the mood: if void civilizations do exist, their version of small talk might literally be, "So, notice any new galaxies lately?" And the answer is always, nope. But science asks more than jokes. Could life really exist in such isolation? The ingredients are the same: hydrogen, helium, heavier elements from past supernova. A void galaxy might have fewer neighbours, but it still forms stars and planets from the same cosmic recipe. If anything, its isolation might give it more time to evolve slowly, without constant galactic mergers to shake things up. Of course, there are challenges. With fewer galaxies around, void galaxies might have less access to fresh gas. Over billions of years they could starve. Running out of fuel for star formation, that means civilizations inside would depend on whatever resources their single galaxy provided. No nearby neighbours to raid, no galactic imports. If they survived, it would be through self-reliance, not interstellar trade. And here's where your imagination spins out. Maybe civilizations in voids are quieter, not because they don't exist, but because they can't expand. With no nearby galaxies to colonize, they're trapped, marooned in their little island universes. Even if they build advanced technology, their signals may never reach us. They'd be swallowed by the vast darkness long before crossing 330 million light-years. The Boötes Void might not be empty of life. It might simply be too far for its life to matter to us. Historians still argue whether voids are dead zones or quiet cradles. Some simulations suggest void galaxies are too sparse to sustain complex civilizations. Others suggest their slower pace of evolution might actually allow more stability. The truth may never be knowable, but the speculation is irresistible. And then comes the eerie thought: what if we had been born in a void galaxy? Our sky would be empty, our science stunted. Would we have ever dreamed of other galaxies? Would we have ever looked outward at all? Perhaps we'd still believe ourselves the centre of creation, never guessing the universe's true scale. In a way, being born outside the void gave us the privilege of perspective. A light joke to ease the chill. Maybe the reason no void civilizations contact us is because their first message would take hundreds of millions of years to arrive. By then, we'll all have long upgraded to telepathy or whatever comes next. Cosmic voicemail at its worst. Yet the possibility remains. Even in emptiness, life could spark. Even in silence, a civilization might rise, look up, and ask the same questions you're asking now. The Boötes Void could be home to voices we'll never hear, stories we'll never know, lights that flicker briefly before being swallowed by the dark. And that's the quiet wonder of the question. It doesn't matter if the answer is yes or no. The act of imagining life inside the void reminds you that emptiness isn't truly empty. It's possibility, stretched thin but still alive. The Boötes Void may be the loneliest place in the cosmos, but even here, the recipe for life remains tucked into the starlight. You've just imagined lonely civilizations huddled in void galaxies, eking out an existence in solitude. But of course, humans rarely stop at reasonable speculation. The Boötes Void is too weird, too vast, too perfectly unsettling for our imaginations to resist. So naturally, beyond the sober explanations of physics and cosmology, there are alternative theories, fringe ideas, playful speculations, and outright conspiracies about why such a gigantic hole exists in the universe at all. The mainstream says voids form naturally from gravitational flows and quantum fluctuations. But fringe thinkers, they see a blank canvas, and when humans see a blank canvas, we paint. Sometimes badly, but we paint anyway. Here's your mainstream historical fact. When Robert Kirshner and colleagues announced the void in 1981, most scientists explained it with large-scale structure models. But almost immediately, writers outside academia spun wilder interpretations. Aliens, hidden universes, simulation glitches. The Boötes Void didn't just stay in science journals, it wandered straight into the cultural twilight zone. And here's your quirky tidbit. One sci-fi fan magazine in the 1980s proposed that the void was actually the parking space for a cosmic battleship, so large that it cleared out galaxies as it maneuvered. They even drew diagrams showing a Death Star meets aircraft carrier drifting in the dark. The article was tongue-in-cheek, but some readers took it dead seriously, mailing angry letters demanding NASA come clean. Historians still argue whether such alternative theories damage public understanding or enrich it. Do they confuse people, making them think science endorses aliens and glitches? Or do they keep curiosity alive, nudging readers toward real cosmology through a doorway of imagination? The debate is still unsettled, and frankly, both sides have a point. Let's stroll through some of the more famous alternative ideas. First, alien engineering. If an advanced civilization had technology far beyond ours, think Kardashev Type 3, harnessing energy at galactic scales, they might have the ability to rearrange stars or even entire galaxies. Could the Boötes Void be the result of such tinkering? Did someone clear it intentionally, like mowing a lawn, to make room for something we can't perceive? Maybe a message, written in absence, maybe a testing ground, maybe just real estate. The idea is tantalizing, but the evidence is thin. Still, it scratches that irresistible itch, the sense that something this big must be deliberate. Humans struggle to accept randomness. When we see a circle in the sky, we imagine a hand that drew it. Then there's the cosmic bubble theory. Some fringe thinkers propose that the Boötes Void isn't just a low-density region, it's literally a different bubble of space-time brushing against ours. In this view, the void might be the scar where universes collided, like soap bubbles pressing against each other in the froth of the multiverse. If true, the Boötes Void could be physical evidence of another universe existing beside ours. A little joke to lighten the speculation. So if the void really is a multiverse bruise, then somewhere out there another universe is pointing at the same spot and saying, "Whoa, what's that weird lump?" Another fringe explanation is the simulation glitch. If reality is a computer program, as some philosophers like Nick Bostrom suggest, then maybe the Boötes Void is an error in the rendering code, the cosmic equivalent of a video game texture that failed to load. It's easy to laugh at, but the idea spread quickly in online forums. The Boötes Void is proof we're living in a simulation. After all, how else do you explain a hole so big, so absurdly empty, unless someone forgot to populate it with galaxies? Historians still argue whether simulation theory is philosophy, science, or just a glorified thought experiment, but it's undeniable that discoveries like the Boötes Void fuel its popularity. When reality glitches this hard, we instinctively blame the programmer. Then there's the truly wild speculation that the void is a wound. Some fringe cosmologists and science fiction writers suggest that the Boötes Void was caused by a catastrophic event, an ancient hypernova chain, a weapon fired by an extinct civilization, or even the collapse of a previous universe bleeding into ours. These explanations sound fantastical, but they're not much stranger than what the void already is. The line between science and myth gets blurry when the cosmos itself looks like a scar, and here's a quirky, almost poetic idea. What if the void is a message? Some writers propose that advanced civilizations could rearrange matter on cosmic scales to leave signals in the structure of the universe. A giant spherical void in this view might be a deliberate beacon, a way of saying, "We were here." If so, the message is painfully ambiguous. Is it a warning, a signature, a cosmic graffiti tag, or just the universe itself doodling in the margins? A joke to break the intensity. If aliens really did carve the Boötes Void as a message, then they must have been trolling us. We spent billions of years arranging galaxies just so, and the humans still called it the Great Nothing. Talk about an unappreciative audience. But even as you laugh, the alternative theories linger in your mind. They remind you of something important. Emptiness begs explanation. When we see abundance, we nod. When we see absence, we squirm. The Boötes Void presses on that instinct, forcing us to invent stories, some rational, some wild, all human. Historians still argue whether we should indulge these stories or swat them away. Some scientists worry that entertaining aliens and glitches muddies the waters, distracting from real physics. Others point out that wonder, even wild wonder, is what draws people into science in the first place. Who among us didn't start with a question that sounded ridiculous at the time? So you float in the void, letting the alternative theories swirl. Alien engineers carving space like sculptors, parallel universes colliding like soap bubbles, simulation glitches leaving black circles in the sky, messages scratched across billions of light years, none of them proven, all of them alluring. And maybe that's the real value of alternative theories. Not that they're true, but that they remind us imagination is part of exploration. Science narrows possibilities with evidence. Culture widens them with stories. Between the two, the void is never just nothing. It's everything we can dream into it. You've entertained all the wild theories, the alien engineers, the simulation glitches, the cosmic bruises. But at some point you have to bring it back to yourself, to us, to the human scale. Because the numbers we've been tossing around, millions, billions, trillions of light years, are so colossal they start to lose meaning. Your brain waves the white flag and files everything under too big to care. So tonight, let's shrink the Boötes Void down, pull it closer, and compare it to the things you actually know. Earthly distances, human lives, time you can feel ticking. First, the raw figure, 330 million light years across. That's a number you can recite but not really imagine. So let's translate. 1 light year is about 6 trillion miles. If you converted that into road trips, driving non-stop at 60 miles per hour, no bathroom breaks, no snack stops, it would take you about 11,000 years to travel just 1 light year. Now multiply that by 330 million. Suddenly, even the most stubborn road tripper gives up, tosses the car keys and says, "Yeah, no thanks." Here's your mainstream historical fact. The Milky Way galaxy is about 100,000 light years across. That sounds impressive until you set it against the Boötes Void, which could fit more than 3,000 Milky Ways end to end. Our galaxy, the home of every star you've ever seen, every life form you've ever imagined, is barely a bead rattling inside that empty marble. And here's your quirky tidbit. Someone once calculated that if the Milky Way were the size of a single US quarter, the Boötes Void would be a disk stretching over 50 feet wide. Imagine tossing your coin into a fountain and realizing the fountain is the size of your neighborhood. Good luck making a wish. Historians still argue whether comparisons like these help or hurt public understanding. Some say scaling down to coins, cars, or marbles trivializes the immensity, making it sound like something you could walk across. Others argue it's the only way to tether imagination to numbers this big. The truth? Probably both. You laugh at the absurdity of the quarter in a neighborhood metaphor, but it also sticks in your head. The void feels bigger when you try to shrink it. Now let's bring in time. Earth is 4.5 billion years old. Dinosaurs dominated for about 165 million years. If you set their entire reign side by side, it wouldn't even get you halfway across the void at light speed. Civilizations rise and fall in the blink of an eye compared to the journey. You'd need thousands upon thousands of human histories, back to back, just to cross the emptiness. It's sobering. Suddenly your to-do list for tomorrow looks refreshingly manageable. But let's make it personal. Imagine yourself in a spaceship travelling at near light speed. You wave goodbye to Earth. A century passes, still nowhere near the far edge. 1,000 years, still adrift in the dark. You'd live and die, generation after generation, without ever reaching the halfway point. The Boötes Void isn't just a distance. It's a graveyard for ambition, a reminder that some places in the universe are simply too big for us to conquer. A light joke to soften the mood. The Boötes Void is basically the universe saying, are we there yet? And the answer, for hundreds of millions of years, is always no. Even at smaller scales, the comparisons are staggering. The entire solar system, including Pluto's orbit, is only about 1 light day wide. That's like a speck of dust compared to the void's cavern. You could stack millions of solar systems into the Boötes Void and still have room for billions more. If space is a warehouse, our little planetary system is a paperclip rattling in the corner. And here's a thought experiment. Shrink the Boötes Void down to the size of a football stadium. In that stadium, the solar system would be smaller than a single grain of sand tossed onto the field. You wouldn't even notice it under your shoe. That's the scale we're talking about. The kind that makes metaphors collapse under their own weight. Historians still argue whether humans are wired to even process such scales. Cognitive psychologists say our brains evolved to track things at the scale of fruit, trees, and maybe herds of animals, not cosmic expanses. When confronted with billions, we reach for metaphors not because they're accurate, but because they give us something to hold on to before our imagination drowns. The Boötes Void is the perfect test case. It exists, it has numbers, but to truly grasp it, you have to shrink it, twist it, bend it into forms your brain can digest. And yet, the shrinking also makes you marvel. If our galaxy is just one bead, and our solar system just one speck, then you, sitting in your room, listening to this, are even smaller, smaller than small, a whisper of existence inside a whisper of a galaxy inside a whisper of the void. And yet, here you are, thinking about it. That alone is staggering. The void dwarfs you, but it also elevates you. Somehow, a being the size of a thought can imagine distances too large for thought itself. A little joke to lighten that deep sigh. If the void ever got a Yelp review, it'd read, 1 star, way too big, no bathrooms, would not recommend. Still, the exercise of scaling matters. It bridges the gap between numbers and awe. You can't walk across 330 million light years, but you can imagine a football field, a quarter, a road trip. The void doesn't shrink, but your mind stretches. And in stretching, you find a way to connect. So you sit there, letting the comparisons wash over you. Coins, football fields, road trips, dinosaur reigns, all swallowed by the immensity of the Boötes Void. And instead of despair, you feel wonder. Because if something this huge can exist, and if you can even partly imagine it, then maybe your own smallness isn't a limitation. Maybe it's an invitation to keep reaching, to keep asking, to keep finding metaphors until the universe runs out of them. You've just wrestled the Boötes Void into human-sized metaphors, coins, football fields, road trips, and still, the emptiness stretches beyond imagination. But once you step back from the scale shock, a new question rises. What does the void actually teach us? Beyond the wow factor, beyond the trivia, beyond the existential size, what lessons hide in this hollow patch of the universe? Because if emptiness this immense exists, it can't just be background scenery. It must have something to say. The first lesson is about balance. The Boötes Void exists because galaxies elsewhere clump together. Matter flows toward filaments, leaving deserts behind. In that way, the void teaches us that structure is defined as much by absence as by presence. Without the hollow, the walls wouldn't stand out. Without silence, sound wouldn't matter. The void is the universe reminding you that negative space is not wasted space. It's essential. Here's your mainstream historical fact. Studies of cosmic voids in the 2000s revealed that they make up about 80% of the universe's volume. That's right. Most of the universe isn't galaxies, but hollows. Filaments and clusters are just the bright outlines. If you drew the cosmos on paper, the ink would be sparse lines. The white background would dominate. The Boötes Void is just one extreme example of a truth written everywhere. Emptiness is the rule, not the exception. And here's your quirky tidbit. One astrophysicist once compared the universe to Swiss cheese. Again, because scientists apparently love cheese metaphors. But this one added a twist. We live in the holes. His point was that galaxies form along the thin edges, while voids dominate the inside. In other words, the cheese part is tiny. The holes are the real bulk, and somewhere, a grad student almost certainly went home craving fondue. Historians still argue whether voids should be treated as secondary features or as central players in cosmology. For decades, they were considered the leftover gaps between the real structures. But increasingly, scientists recognize that voids aren't just passive. They shape how galaxies grow, how dark energy behaves, even how the cosmic web itself stretches. The debate continues. Are voids supporting actors, or are they the stage itself? For you, the void offers a second lesson, perspective. Standing on Earth, you often feel the weight of your worries, the crowded bus, the endless emails. But compared to the Boötes Void, your problems shrink into dust motes. Emptiness this grand reminds you how small you are, and paradoxically, how big your thoughts can be. A being made of atoms living less than a century can still imagine hundreds of millions of light years. That's not nothing. That's astonishing. A light joke here. If the void teaches humility, it's basically the universe's way of saying, calm down, Karen, your latte order isn't the end of the world. The void also teaches patience. Galaxies evolve differently in isolation. Star formation slows, mergers are rare, change comes glacially. The Boötes Void whispers that not all growth is fast, not all progress is noisy. Sometimes, the most important changes happen in silence, stretched over billions of years. In a culture obsessed with speed, that's a strangely comforting lesson. Another insight is fragility. The few galaxies inside the void are fragile outposts, isolated and self-reliant. They remind us that life, if it exists there, must be resilient, resourceful, capable of surviving without constant connection. The void teaches that connection is a privilege, not a guarantee. In our filament-rich neighbourhood, we take abundance for granted. The void humbles us, showing how rare that abundance really is. Historians still argue whether our location in a relatively crowded region of the universe shaped the course of science itself. Some suggest that if humanity had been born in a void galaxy, we might never have discovered the true scale of the cosmos. Without visible neighbours, our telescopes might have concluded wrongly that the universe ended just beyond our stars. In that sense, the Boötes Void teaches gratitude. Our view is a gift, not a given. Then there's the philosophical layer. Emptiness often frightens us, whether cosmic or personal. But the Boötes Void reframes it. Emptiness isn't just absence, it's structure. It holds meaning not in spite of being empty, but because of it. The void teaches that absence is not failure. It's space for imagination, for possibility, for balance. A playful joke. If the void were a teacher, it'd be that one professor who stares silently at the class for 30 seconds, waiting for someone to speak. Awkward, yes, but effective. Another lesson lies in humility toward mystery. The Boötes Void still isn't fully explained. Are its galaxies native or ejected? Is its shape a perfect sphere or a composite of smaller voids? Does it reveal something profound about dark energy? Or is it simply a statistical outlier? The void teaches us that not all questions have neat answers. Sometimes the lesson is to keep asking. And finally, the void teaches awe. You've floated through it in imagination, scaled it down to football fields and coins, compared it to deserts and oceans, joked about Yelp reviews. And yet, even with all that scaffolding, the raw fact of its size and emptiness still makes your breath catch. That's awe. The moment when language collapses, jokes stumble, metaphors strain, and all you can do is sit quietly and let the enormity wash over you. So, what does the Boötes Void teach? Balance, perspective, patience, fragility, gratitude, mystery, awe. Not bad for a patch of nothing. You've gathered the lessons, the patience, the perspective, the balance, and you might think the Boötes Void has given up all its secrets, but no. For all the measurements, metaphors, and simulations, the void still refuses to be fully explained. Like a puzzle missing its last few pieces, it taunts astronomers with lingering mysteries, questions that remain unanswered, debates that haven't settled, shadows in the darkness that whisper, "Not so fast." The first mystery is origin. We know voids come from underdense regions in the early universe, but why did this void grow so absurdly large? Simulations can produce voids, but the Boötes Void is still on the extreme end, a statistical outlier. Did it form naturally, or is there something about its environment, maybe the pull of nearby structures, that exaggerated its growth? It's like finding a pothole the size of Kansas on an otherwise bumpy road. Ordinary physics can explain it, but not comfortably. Here's your mainstream historical fact. In the 2000s, astronomers using the Sloan Digital Sky Survey tried to model the Boötes Void within the cosmic web. They found that while its size was unusual, it wasn't impossible under LCDM cosmology, the standard model with dark matter and dark energy. Still, the probability of such a void forming is low, less than 1 in 100 by some estimates. That keeps eyebrows raised. And here's your quirky tidbit. One astronomer once called the Boötes Void the Bermuda Triangle of cosmology, half joking that galaxies seemed to have vanished mysteriously. Of course, they hadn't, but the metaphor stuck, and now you can find it lurking in old magazines, right next to UFO stories and crop circles. Historians still argue whether the Boötes Void should be treated as a single entity or as an overlapping cluster of smaller voids. Is it one giant bubble, or a set of bubbles fused together like soap suds? The answer matters, because it changes how we calculate its likelihood. To this day, the question is unresolved. Another mystery: the galaxies inside. How did they end up there? Were they born in situ from small patches of leftover gas? Or were they flung into the void by gravitational tides, cosmic exiles swept away from clusters? The few lonely spirals and dwarfs inside the void are like fossils, clues to the past. But interpreting them isn't easy. They don't evolve the same way as cluster galaxies, and their isolation makes them tricky to compare. Then there's the role of dark energy. We know voids expand faster than denser regions, but could the Boötes Void be telling us something deeper? Some researchers speculate that its size and shape might hint at variations in dark energy's strength, or even at new physics beyond our current models. If voids grow too fast, they might be whispering secrets about the very fabric of space-time. A light joke to ease the tension. Maybe dark energy is just the universe's version of procrastination. I'll get around to forming galaxies later. For now, let's just leave a big empty patch. Another mystery lies in the so-called cold spot connection. Remember section 11? Some studies hinted that large voids could explain cold patches in the cosmic microwave background. But the jury's still out. Could the Boötes Void, or voids like it, be leaving subtle fingerprints on the oldest light in the universe? Or are we forcing a link where none exists? The debate is ongoing, and the void sits there, sphinx-like, offering no clarifications. And then there are the human questions, the speculative ones. Could life exist inside the void? You've pondered that already, but the mystery remains. What philosophies would such civilizations form? Would they ever detect us? Would we ever detect them? It's less about astrophysics and more about anthropology on steroids, but it's a mystery nonetheless. Historians still argue whether the Boötes Void deserves its fame at all. Some say it's just a statistical curiosity, overhyped because it was discovered early. Others defend it as a landmark, the first void big enough to shake assumptions. The mystery isn't just the void itself, it's our relationship to it. Do we see it as a scientific challenge, or as a cultural Rorschach test? You float in the middle, listening to the silence, and realise that the Boötes Void's greatest mystery may be why it affects us so much. It doesn't threaten us, it doesn't swallow stars, it's just emptiness. And yet, emptiness unsettles us more than fullness ever could. Maybe the real puzzle is why humans, creatures who can barely walk across a continent without needing coffee, are so obsessed with understanding a bubble hundreds of millions of light years wide. Another playful joke: if the void had a motto, it would be, "I don't owe you answers," and honestly, fair enough. But mysteries are invitations, not roadblocks. The Boötes Void invites us to refine our models, to test our ideas, to stretch our imaginations. Each lingering question is a thread tugging us deeper into the tapestry. And maybe that's the point. The void doesn't need to be solved to be valuable. Its value is in the pursuit. So you sit there, surrounded by silence, listing the mysteries like constellations. How did it form? Why so big? What do its galaxies reveal? What does it say about dark energy? Is it one void or many? Does it shape the microwave background? Could life exist here? Should we even call it one thing? Each question dangles, unanswered, like stars that never quite lit. And maybe that's the final lesson. Not every emptiness needs filling. Sometimes the unanswered is what keeps us looking up. You linger among the lingering mysteries, questions stacked like unopened letters, and at last you let yourself drift. The Boötes Void stretches around you, the great nothing, silent and endless. It's not hostile, not dangerous, not pulling you apart like a black hole. It simply is. A space where galaxies should exist but don't, where light crosses unbothered, where silence reigns. And in that silence, you begin to feel something unexpected. Calm. At first, you thought of the void as terrifying. A yawning desert of stars, a scar in the cosmic web. But the longer you stay, the more it feels like a sanctuary. Free from clutter, free from noise, free from the drama of colliding clusters and erupting quasars. Here, nothing demands your attention. Nothing jostles for your place. The universe, for once, leaves you completely alone. Here's your mainstream historical fact. Modern surveys suggest that cosmic voids may actually dominate our universe's shape more than clusters do. If you drew a random line through the cosmos, it's more likely to pass through a void than through a filament. In other words, nothingness is the normal state of things. Galaxies are the exceptions. The Boötes Void simply makes that normality visible at absurd scale. And here's your quirky tidbit. One astronomer once quipped that if we really want peace and quiet, we should skip Mars colonization and head straight for a void galaxy. No noisy neighbours, no meddling supernova, just cosmic introvert bliss. The joke, of course, ended with, bring a lot of snacks. Historians still argue whether the Boötes Void should be considered an outlier or just an exaggerated version of cosmic norms. But for you, the debate hardly matters anymore, whether rare or routine. The void feels profound. It teaches not just science, but perspective, patience, and maybe even acceptance. As you drift, you imagine yourself switching off the ship's engines. No hum, no vibration, just the silence of your own breath in your helmet. Around you, a handful of galaxies glow faintly, like porch lights left on for travellers who never arrive. Beyond them, walls and filaments blaze at the edges, distant cities sparkling across the horizon. But in here, stillness. You realise the Boötes Void isn't empty at all. It's full of something rarer than galaxies, space to think. It holds room for imagination, for speculation, for humility. It's where science collides with wonder, where data meets myth, where absence becomes presence. The void doesn't threaten, it invites. A light joke as you settle in. If the void had Yelp reviews, it'd earn 5 stars from introverts, 1 star from extroverts, and a warning label from anyone who forgot their flashlight. And then you close your eyes, letting the dark wrap around you. The Boötes Void, the great nothing, has become your lullaby. Not scary, not lonely, just quiet. A place where the universe finally whispers, rest. Wind down, 300 words. And so, as you sink deeper into that silence, the pace of your thoughts slows. The numbers and debates, the theories and speculations fade into the background like distant radio static. What remains is the hush, the vast, unbroken calm of a space too large to measure and too patient to rush. You imagine the void not as absence, but as a kind of blanket stretched across the cosmos. Soft, dark, cool. Its stillness feels less like loneliness and more like serenity. A reminder that even the universe itself pauses, rests, leaves room between its brightest notes. You picture galaxies at the edges, twinkling like candles far away, their light faint but steady. Inside, nothing intrudes. Inside, you are safe. Your breath slows to match the rhythm of that emptiness. Each inhale fills with the quiet of 300 million light years. Each exhale releases the clutter of the day. The silence is not heavy, it is light, floating, buoyant. Like drifting on calm water at night, nothing but the sound of your own heartbeat. If you listen closely, you almost hear the void humming, a soundless vibration, a reminder that even in nothing, there is presence. You let that imagined hum cradle you, as steady as a fan in the corner of your room, as gentle as a lullaby. The Boötes Void will still be here tomorrow, and the day after, and long after. You don't need to solve it. You don't need to cross it. You only need to rest in its stillness for now. So close your eyes, let the darkness soften, and drift off in the great nothing. Sweet dreams.